All right. Make sure my chat is up so I can see in case someone types chat out. There we go. All right. So we touched on a few things yesterday. Probably, and some of it was this was the day before, but we talked a little bit about scaling on demand. So we talked about auto scaling, basically understanding how we can actually just stay just ahead of demand from a capacity standpoint. So just making sure the capacity stays ahead of demand. You know, obviously performance efficiency and cost optimization are two real keys there, right? And so we talked about auto scaling, which auto scaling basically is the kind of wrapper for EC2 that makes it actually super cost effective in the cloud. And that you could actually trigger auto scaling based on a bunch of different conditions, including manually, based on time, based on other services actually. But mainly it's typically metrics driven. And we talked about the three components of auto scaling, which is the launch configuration template, the auto scaling groups, and the auto scaling policy. We talked about how with the launch configuration versus templates, obviously launch templates are the preferred. They have all the features and you can actually version them. And then auto scaling groups actually define min and max, and then auto scaling policies actually trigger like what you do when certain conditions are met and or exceeded. So we dived into launch templates and got into details. We talked about auto scaling groups in terms of attaching load balancer, which is the typical way that auto scaling groups are used. Typically, there's this trifecta of load balancer, CloudWatch, and auto scaling, right? That works together. So auto scaling, load balancer, and CloudWatch typically go together to make up a truly like auto scaled kind of group of EC2 virtual machines. We also talked about health checks, how healthy instances get replaced, how you can set min and max. And then we talked about scaling policies, including the different types of dynamic scaling. So there was scheduled scaling, and there were three types of dynamic scaling. There was simple, step, and then there was target tracking. And then we talked about predictive scaling, of which two of those can be combined, which is the target tracking dynamic plus the predictive scaling. And then we talked about how you can control the termination policy. There was also just a brief mention of like you can actually create fleets of spot instances and on-demand instances so that you can actually mix and match to get the maximum amount of efficiency out of your auto scaling group, right? And remember, spot instances are the ones that give the 2-minute warning when Amazon needs to take them back because someone else is willing to pay for them. And then we mentioned license manager, which basically allows you to input the details of your contract, enforce the license limit, and then attach that to AMIs to either prevent or stay in compliance with licensing. Did some troubleshooting. And that was it pretty much for auto scaling. For the next section, monitoring and maintenance, we basically centered pretty much everything on CloudWatch, right? It was pretty much all about CloudWatch, although there's other pieces in here as well. But basically how to collect, monitor, analyze, and respond to all of the different things that can pop up inside of a metric, right? And so we skimmed certain portions of CloudWatch, talking about the metrics portion, the dashboards portion, the alarms, the logs, events, and of course we mentioned the CloudWatch agent, which is like the SSM agent is required to really get detailed metrics from inside the operating system. And we talked about CloudWatch monitoring, all the different ways in which you can get access to statistics. And then we talked about the dimensions of the different metrics, right? As well as standard metrics versus custom metrics, how to enable detailed monitoring, which allows you to change from 5-minute intervals to 1-minute intervals for EC2 instances, how you can actually do custom metrics at like 1, 5, 10, and 30-second intervals below a minute, right? We talked about the different retention periods, which basically after 63 days, everything gets aggregated down to an hour of like resolution. After 15 days, pretty much everything gets resolved down to a 5-minute resolution. So, and then we talked about anomaly detection, and we actually turned that on when I found the right tab right under graph metrics, which then allowed you to start doing predictive analysis against the metrics that it does have. Note that when we did that, the only thing you could do is set up exclusion ranges. You couldn't actually like bookend the time, right? It just used everything you had. We talked about dashboards and just like talked about the different widgets. And then we talked about alarms, how you create thresholds, and then 3 different states for alarms, including insufficient data, which was super important. I mentioned this shows up on the exam. And then we talked about logs, and just that you could put logs inside of CloudWatch, and that you actually could create a dashboard, and you can actually use CloudWatch log insights to actually search your logs, whether they're custom logs or published by AWS services. And then we mentioned that you could put alarms on certain logs and metrics, filtering for either terms, phrases, or numbers, right? So it just depends. And there's CloudWatch Logs Insights, where we're actually using it to actually run a query, getting results, much like you would if you were using like a Kibana or a Tableau or something along those lines. We also mentioned that you could actually put this in an elk stack, and I think we mentioned Grafana and Kibana for this. But basically, you could pull off the Elasticsearch data store and create pretty dashboards, right? Get information, search, correlate. And then events, which we had mentioned has been kind of extended and renamed to EventBridge, which is what they talked about. And this followed the pattern of having an event source that triggers some kind of target. So if like a pattern or even on a schedule, something shows up, you can actually create event rules that trigger certain responses. And so we did obviously mention about how cloud, EventBridge is supposed to be evolving into this event-driven architecture. So, and then we talked in general about the personal health dashboard, kind of as a way to see how service outages on AWS's side impact your particular infrastructure. We also talked about monitoring and tracing distributed applications, which this is where X-Ray comes into play, right? As well as Service Lens, which is in a sense, kind of a separate service, but it uses X-Ray information to kind of create a service map of what's happening. And then we talked about Trusted Advisor and the Limit Monitor, right? Has ways in which you can actually just monitor what's going on with service quotas and best practices inside your account. And then we did a little troubleshooting about insufficient data states and how to, basically restart a CloudWatch agent. And that was that particular module. And then we obviously did Lab 4, right? Which had us basically manipulating a bunch of CloudWatch information, systems manager information, subscribing to a topic, and creating some CloudWatch alarms. Okay. Stop me at any time if you have questions about any of that content. All right, and then we talked about data security, which a lot of it was about permissions management. So we talked about the access analyzer, which basically governed resource-based policies, not user-based, like identity-based policies, and how to create an analyzer. And we actually went into my account because I had a Cognito, I don't say what I'm saying, Cognito analyzer. And then we talked about permission boundaries. We had a little bit of discussion around that. It's not my favorite product, but I'm sure there's great use cases for it. Basically, it's an allow list for how you can actually scope and delegate administration permissions to other users other than administrators. So you can actually delegate admin privileges to, say, like a developer. Talked about like how it reconciles, right? Permissions. So basically, if it's not allowed on the permission boundary, it's not going to be allowed on the identity-based policy, right? Then we talked about a bunch of services around detection and auditing, ranging from API tracking with CloudTrail, state tracking with config, so configuration state tracking, VPC, threat detection, which is what guard duty really is, and then inspector, which is vulnerability assessment, right? So we talked about those various services, including the CloudTrail format header, doing log analysis against CloudTrail logs with Amazon Athena, which is this cool little tool that will read S3 structured data. And then talked about config rules, which looked more remarkably like event rules inside of EventBridge, and which we've seen config before, so that wasn't a surprise. And then guard duty, which you literally just turn on, and it basically starts reporting findings as soon as it gets the CloudTrail events, the flow logs, and the DNS logs analyzed, right? And then Amazon Inspector, which is a vulnerability assessment tool that basically detects vulnerabilities and remediates findings back to you. It does require an agent if you really want in-depth response. And then we moved past detection into incident response and automated remediation. And this is where config could trigger CloudWatch events, which could trigger a Lambda, or it could trigger actually, fleet systems manager automation responses, right? And we talked about how you can manage remediation inside by adding, remediation to your rules, like a remediation action, and setting up a remediation action, right? It could be manual, it could be automatic, but automatic would be running these documents. And then, since Lambda was always woven in here, we just talked briefly about Lambda as a, basically functions, as a service. So no servers to manage, you just dump your code and it goes. So Lambda, this is obviously the chain of like, hey, I got CloudTrail talking to CloudWatch, which is talking to CloudWatch events, which then triggers a Lambda, which may send a notification or remediate the issue, whatever is necessary there. And so we went through creating a strong identity foundation, detection mechanisms, and incident recognitions, and we did some troubleshooting where it's like, oh, hi, we're in here in a config rule, and I need more details. How do we get more details about what's happening? Well, you click on the details button on the right-hand side, little details section. And some troubleshooting with the CLI output, right? In this case, was a permissions issue. They did not have put bucket encryption operation. They were denied. All right, and so that was all related to data security. And then last, but certainly not least, we dove into a pretty large topic around basically operating secure and resilient networks. So in this particular case, we went through on how to build and secure networks. So we talked about all the different like cores or options as far as going from the operating system all the way out to the VPC to even to the internet and beyond. And so we talked about the different like stateful and stateless firewalls that exist at these levels, including the route tables, which are not firewalls, obviously, but without them, you can't find networks inside of AWS. And then we also talked about networking at the edge with CloudFront, which is a content distribution network that allows you to push static content out closer to your users, and also with web application firewalls, which are filtering functions that filter legitimate traffic versus malicious traffic. So, and then certificate manager, which especially if you use Amazon to request your certificates and it's associated with an Amazon device, they'll automatically renew your certificates. So we went through that in detail, talked about private versus public subnets, talked about the route tables that are required to like hook in, for example, to an internet gateway in this particular case. We also added in a NAT gateway to show that the NAT gateway needed to be on a public subnet and that a private subnet needs an entry to the NAT gateway for the NAT gateway to be in line. And then we talk about NACLs, which are the stateless firewalls that surround every single subnet. They are off by default. You have to turn them on. And then here was an example of the rule order precedence, which you're used to if you've done this in Linux, that is followed for network ACLs. And then we talked about security groups, which are the firewalls that wrap around EC2 instances, particularly the NICs. So if you stick a network card anywhere, even if it's not with an operating system, which you can do, it has a security group around it, so you can control access to it. These are stateful firewalls, so you only need one rule for both sending and receiving traffic from the same session, same request. Here was an example of the allow rules, because you can't deny with security groups because everything's denied by default. You can only allow. If you need to block an IP range, you have to use NACLs. You can't use security groups. Then we talked about how to connect, VPCs together. VPC peering was one option. You could also, by the way, hook in your corporate, data center in as well using VPN connection. It is worth mentioning also is that you can actually run a physical cable from your data center over to Amazon. It's called Direct Connect. Sometimes it's shorthanded as DX. You can get a 1, a 10, or 100 gigabit. Sorry, is that right? Hold on one second. I think it's sorry, I'm going to say megabit. I think it's a megabit connection between your data center and Amazon's. I could be wrong about that. It might go faster. I don't know why I'm getting that confused. but they just actually added 100 in, so you should just be 1 in 10. I think it's megabit. It could be gigabit. I think actually it's probably gigabit. I don't know what I'm thinking there. It is 2021, isn't it? So you can actually get a physical connection if you want to. So that's worth mentioning, is that if you have a direct connection from your corporate data center into Amazon, you can manage it using the transit gateway, which is the thing that we were talking about yesterday for VPCs and VPNs. So just know if you do have a physical connection, you can manage how that's routed through to Amazon as well. We talked about gateway endpoints and interface endpoints, of which there's only 2 services that have gateway endpoints. That was DynamoDB and S3. Everything else is an interface endpoint. So what this does is this allows you to access services that you normally have to go public for. You can now access them privately from your VPC without having to go through a NAT gateway or through an internet gateway. So this allows you to talk to public services without exposing your subnets to public, right? And then, we mentioned that every single subnet has basically a DNS resolver, right? And so every VPC has this. And then we talked about flow logs, which has details on like the flow of packets from network card to network card inside of AWS, including services, so service and network card. And then we talked about CloudFront has a global distributor or cache of content and how that actually functions. And then we talked about the various settings for that, how to expire content, those kind of things. And then we talked about WAF, which is that filtering function that basically protects illegitimate traffic from getting through to either your CloudFront distribution, like your load balancer or your API calls. You could also put this in front of a web server, by the way. So don't be fooled. You can, once it's in front of a load balancer, you can put it in front of anything. Talked about there are managed rules that Amazon provides. There's also custom rules that you can create. So, and then there was Shield. So Shield was the service that came with every single AWS account that basically protects against distributed denial of service attacks. And you can get the advanced version, which gives you, I think you have to dedicate for a year, but it basically gives you enhanced protection and access to a DDoS response team. And then we talked about Certificate Manager, which I think we touched on before, but we went through and talked about, how you can use that to renew certificates, create private certificates, create a CA, a hierarchy, and not have to manage with either private or public key infrastructure. Did a little bit of troubleshooting about, the fun, and I think this was fairly fundamental, just, how to troubleshoot the network, how to check your firewalls, how to check your route tables, checking the VPC flow logs to see how things are flowing through the network. And then NAT configurations, just checking to make sure that your NAT is on a public subnet and that there's a clean route table association for it. David, thank you for the reminder. Yeah, gigabyte. Sure, probably need some more coffee. And then how to peer, what do you check when peering networks, especially like the request approval, the peering request, which is under VPCs, under peering requests now. It's no longer under just VPCs. And that was it. That was networking yesterday. That's what we covered. Any questions at all about any of that content? No? Okay, let me log into this really quick. Okay. Well, if that's the case, we are on to this next thing here. Let's see here. Mountable storage. Okay, let me go ahead and queue up the lab. So we've got this lab today, and then we've got our capstone lab, and then we're going to spend a lot of time. We're going to spend at least an hour basically going through some training material, answering questions, kind of getting prepped for the exam. A reminder that as our brain slow down, I probably will be checking in towards the last half hour or so, just to make sure people are still engaged. I'll ask at the time, but if it's not useful to people, if people are like, yeah, let's call it, we will end a little early. Otherwise, we can go straight till 5. I have no issues there. Okay. Before we do that, it's 8:55. If we can, let's just take a short 10-minute break. Let's come back at 5 after. I just need to grab a quick glass of water before we roll into this. And this is actually a relatively short module, so it works for us because I also need a little bit more time to pre-warm the labs. So let's take a 10-minute break. Let's come back at 5 after. Okay. All right. Thanks, everyone. Okay, we're back. Questions? Anything else about the review that we just did before we roll into the rest of the rest of the day? Okay. So let's talk about mountable storage. So this is going to be a pretty detailed conversation about basically EBS, things that can manage EBS, EFS and FSX, which are kind of like network file shares, if like the best way to say it. And this is all storage that is mountable inside of an operating system. So this is not object storage where you have to use an API to put an object and retrieve the entire object. This can actually be mountable as either a drive letter in Windows or a path inside of a Linux file system. Excuse me. The weather is going crazy over here. So we're going to talk about mountable storage. That's basically what we're doing. So in our example corp, like as cost for resources climb, what's happening is that you are asked as a system admin to develop a way to optimize data storage, but also data lifecycle management. It includes some classification of data, identifying PII. You also probably need to establish some lifecycle storage rules and plan for backup and recovery. So, yeah. So take a moment to just drink this in for a second. I'm going to pause here for just a moment so that we can take a look at this. So you'll see here that, we've got, EC2 virtual machines that are our host computers, and they're running on a hypervisor that also has local hard drives. They're called ephemeral drives. They're also known as instant storage. In general, we do not use instant storage because they are very tricky. And when we use instant storage, even though it can be fast storage, it's ephemeral, which means that when you delete the instance or the instance crashes, you automatically lose access to that hard drive. You can't even, you can't stop these machines either. You can restart them, but they're gonna restart on the same host. And that's the problem, is that these virtual machines now lose resiliency and persistent access to their data because those ephemeral drives that are right beneath the instances, they are ephemeral, which means short-lived. So instant storage is still available for some of the AMIs that are out there for the EC2 virtual machines, but you just want to be mindful because you really need to know how to use these things properly. Like basically taking into an account that these things are going to go away. The drives are going to go away if the instances crash, or if they're stopped, which they can't be stopped. They can only be terminated, actually. So the other thing is that then you've got EBS storage, and then you've got S3 storage, and then you've got S3 Glacier, which S3 Glacier, S3 infrequent access, all of the other S3 types of storage are really divided between S3 and Glacier. Glacier is archival storage, and all the flavors of S3, you still have access to it. But with Glacier, you don't really have direct access. There's no availability of your objects anymore. So we're going to talk about that. And then on the far left, you've got EFS and FSX, which are basically shared file systems, either for NFS or Windows like CIFS, like SMB kind of thing. So, and there's a bunch of like nuances here. But in general, this is all of the mountable and unmountable storage. Now, as far as mountable storage options go, we are only talking in this module about EBS and EFS FSX. So the two that are right around the EC2 instances. We're not going to be talking about S3 or S3 Glacier until the next module, okay? The reason for that is that that's all mountable storage. The rest of this is the S3 and S3 Glacier is not truly mountable storage. Don't get me wrong. People have created tools to mount S3 and not really Glacier because that's not available, but to mount S3 into a file system, but that is not what it was intended for, and it's horribly performant. So it barely works. Now with an EC2 instant store and EBS, I mentioned this before, is that instant storage is this storage that's like on the actual hypervisor host. It's actually NVMe RAM SSD disks that are actually on the hypervisor. So that's what instant storage is. Now, this is directly attached block level storage to the virtual machine on the hypervisor host that the virtual machine is on. That comes with some caveats. This is great for temporary data, like a page file. It's great for caching. It's great for buffers. It is not great for persistent data. I hope I've said that enough. If you look, you can find the instance store types, because if you look when you go to choose an instance type inside the console, you'll see where it says instance storage, EBS only, right? Which means you have to use EBS, or it'll say 50 gigabytes of SSD or 100 gigabytes of SSD or some other variation, right? Those are instant storage instances. Most of the time, people will use the instant storage instances and they won't even look at the storage. They won't even use the instant storage, right? They're going to use an EBS volume instead. You get a lot more control and it's persistent data at that point. Now, if we are avoiding the use of instant storage, then the other option is that we have to use EBS. EBS, Elastic Block Store, is the actual hard drive service for EC2. Instant storage is just something that happened to be there, left over from the early days. It's only gotten faster because because SSDs have gotten faster. But again, most people don't use it. They avoid it like the plague, right? EBS is where most people get their hard drives for their systems. Now, this is network attached because it's not directly on the host. But just to say this is using iSCSI, and Amazon has gotten incredibly efficient at providing ridiculous performance for these volumes. I saw a thing the other day. They have this thing called EBS Block Express. This thing gives you 256,000 IO operations per second on a hard drive, 256,000. And it's not at 4 kilobyte chunk sizes, it's at 256 kilobyte chunk sizes, which is a ridiculous amount of throughput that you can run through a single volume. Now, I'm sure you pay through, you pay commensurate with your performance, and I'm sure that's the largest volume available. But the fact that they can even reach across the network and get 256,000 IOPS at a 256K chunk size, that's magnificent. So Amazon's really figuring it out. Now, even for the standard volumes because there's different volume types available in EBS, even for the standard volume types, the numbers are quasi ridiculous, right? So, but this is network attached storage. It's persistent, which means that if the virtual machine is deleted, it doesn't necessarily mean that the disk drive is deleted. Now you can tie them together, right? So that when you delete the virtual machine, the hard drive goes away, but that doesn't have to be the case. One thing I discovered on accident before they officially announced it is that I was messing around with an EBS volume like a couple months ago, and I noticed that it had a feature where you could multi-attach it to multiple EC2 instances. By the way, don't do that unless you have a cluster file system on your hard drive. These volumes are not really meant for shared storage. That's what the shared storage services are for. But if you have that rare use case where you need multiple systems to write to a clustered file system, or maybe just mount them read-only, you can do that. But I just want to be clear is that this hard drive service is really not for shared storage. Those should be edge cases. They should not be core cases, because there's a bunch of considerations when you have multiple operating systems writing to the same disk. Okay. The other thing to remember is that virtual machines are tied to an availability zone inside of a region. EBS volumes are also tied to an availability zone inside of a region. So you're not going to be able to multi-attach, for example, across a bunch of regions like you can with EFS or FSX. So just another kind of caveat for the multi-attach feature. Now, there are two families. There's the SSD family, and then there's the mechanical HDD family. And by the way, the old magnetic drives from like 2010 are actually still listed inside the console. Please don't use those either. The old magnetic drives are a travesty. Please do not use them. But if you see SSDs like GP3 or IO2, or you see ST1 or SC1, those are all valid types. This right here that's on the slide deck, these are the general purpose and the provisioned IO volumes. GP3 and IO2 are the like short names for provisioned IOPS and general purpose. There is a GP2, but like a year ago or so, they came out with GP3, which is not only cheaper, but faster. So there's general purpose SSD volumes and there's provisioned IOPS volumes. With general purpose, right, these are optimized for small, frequent read-write operations with a small IO size, where the dominant performance attribute is IO operations per second. So these SSD-backed volumes are built for IOPS, right? The other drives, the HDD-backed volumes, are optimized for streaming sequential workloads, where it's like the total amount of data transferred per second. But I just got to tell you, most people end up using the SSD-backed types because they actually don't know what their disk performance workload looks like. And these are the only volumes that you can boot off of. You can't boot off the mechanical drives. So most people don't even bother with the mechanical drives unless they have some kind of data warehousing archival function, right? Just FYI. One thing to note is that if you're on the exam and they're like, and they're saying, I have a database high throughput workload with high IO requirements and it's a database, the answer is, from Amazon's perspective, is always provisioned IOPS. So if you ever ask the question on the exam and they're like, yeah, I've got a high throughput intensive database workload, which disk should I use for this? The answer is going to be provisioned IOPS almost always, right? So just something to keep in mind from a test perspective. Other than that, general purpose is going to be your friend. Now, general purpose can cap out at a maximum of either 3 IO per gigabyte, like allocated. So for example, if you have, a 1 terabyte volume, you're going to get about 3,000 IOPS, right? Just know that you do get a minimum of 100 IOPS no matter what size you allocate. So if you give it a gig, you're going to get 100 IOPS regardless, right? So it's not like you're going to fall below the minimum. The minimum amount of transfer throughput is going to be 128 megabytes per second, as you see there. Max is going to be 250 megabytes. It can burst. So like it can be burst beyond, right, the expected allowance. But just know that these typically cap out at 16,000 IO per second, which is pretty nice. General purpose volumes that are smaller than a terabyte can occasionally burst to a 3,000 IO per second. But there's like a credit allowance that allows the volume to do that. And once it's out of credits, it will no longer be bursty. So just know, if all of a sudden you see your disk drives suddenly hit a performance limit because they've been bursting the entire time and they ran out of like credits to burst, if you see a sudden shift in your disk performance, it's probably because you actually need to get to a higher IO profile. So, one thing to pay attention to is when you launch an instance that workload who hasn't been running for a minute and you see a decrease in disk performance, go check your what's called your burst credit allowance. I'm actually going to type that in chat. Inside of CloudWatch, because that means that your disk drive might be less performant because it ran out of free credits to burst, right? So there's a couple of breakpoints here, by the way. At like 334 gigabytes, volumes that are like that size or larger, you're gonna hit the 250 megabyte like limit, right? Yeah. So there's like a couple of breakpoints, like if it's smaller than 170 or, but not yet quite smaller than 334, it's going to deliver a maximum throughput of 250 if burst credits are available. In other words, there are burst credits on this whole thing that basically means that you can actually burst in many cases. So the funny thing about this is that you might actually end up allocating a larger volume size than you actually need, not because you need the space, but because you need the performance profile. So make sure you're doing the math here around how these general purpose volumes work. In general, if you're at 1 terabyte volume, if that's like just your standard minimum size, regardless of how much space you need, you're going to be at the maximum performance profile. So you'll be fine. Unless you need more IOPS. So this is something to keep in mind. In order to get to the 16,000 IO per second, you have to divide 3 into 16,000, and that'll get you to your max. So it'll be about 5 terabyte volume.
Hey, can I interrupt real quick?
Oh, hey, Greg. Good morning. Go right ahead.
Good morning, everybody. Sorry to interrupt our regularly scheduled programming for a special announcement, but I just want to make sure that everybody has received access to their licensing to do the practice exams. There's a few people yesterday that didn't have them yet, but they do have them now. But I think most people are all set. But let me, I think most of you have my email address already, but let me post my.
I
What's that?
posted it again yesterday, so go right ahead.
Okay.
Yeah.
So if anybody does still need something, licensing or access to the study guide that I'm sure Michael has shared with you as well, just let me know. And any questions in general, again, you have my email, so certainly keep me posted. I hope everything's going well with the class, and I wish you well on your efforts to pass the certification exam. And do feel free to reach out to myself and Michael post training if you do have any extra questions that we can help with as you prepare to study. And that was it.
Awesome. Always good to see you, Greg.
Yeah, good seeing you as well. I'll talk to you. Oh, we're talking later this week, right, Michael? We'll figure
Absolutely.
that out. Okay. All right, folks. Enjoy the class. Take care.
All right. Good. And I'll make sure, by the way, again, that we repost the Greg's information and my information. And of course, we are available to you after class. So if you have questions, just let us know. All right. So back to this. So now we've switched off of general purpose IOPS, and now we're on to provisioned IOPS. Now, this is another volume type, right? So it's not general purpose. This is usually referred to as IO2 now. There is an IO1, but try to use IO2. Cheaper and faster, right? Remember that. Now, this is interesting because this will allow you to turn the dial on the number of IOs that you want, right? So instead of delivering an average of 3 IO per gigabyte of allocated storage, you basically just set the IO rate that you want. The minimum's 100, but you can basically set up to a maximum of 500 IOPS per second per gigabyte of storage space. So for example, following the math there, if you have 1,000 gigabytes or you have a terabyte, right? Or TB is probably the technical term. Right, what will happen is if you multiply that times 500, that will tell you the maximum number, right? So what would that be? 500,000? I don't even know if it goes that high, actually. The maximum is actually 64,000. So, and actually, I want to say that actually lifted recently. I want to say that's now close. I think they're about to release that to 128, actually. Regardless, obviously you need to choose the size that's going to get you to what you need. But as long as you have, you can basically turn the dial on the kind of IOPS that you want, right? Per volume. Now, just to say this, you obviously, the faster you go with the dial, the more money you pay, which is, I think, standard, right? And so when you come out here and you're like, I need to guarantee that I have consistent IO and throughput, right? Then, this is what you use provisioned IOPS. I will tell you, for the most part, most people stick with GP3. They use general purpose, and it's totally solid. If you hit the limits of GP3 in your performance testing and you're like, this isn't working, you could literally attach a provisioned IO volume and rotate your data over there in the operating system and move it all over, and you can go to town. What's cool about this also is that with certain services like RDS, the relational database service, you can actually convert your GP3 volumes over to IO2, like on the fly, which is kind of nice. And you can actually get the consistent IO profile that you need, right? So to give you an example, by the way, a 50 gigabyte volume can have its performance level set between 100 IOPS, which is the minimum, to 25,000 IOPS, because 50 times 500 is 25,000. So it's not like you need to get to a terabyte to get to 64,000. It doesn't require that at all, right? Because 100 gigabyte volume will get you to 50,000 IOPS. So it's not like you need to go to a terabyte to get extreme performance. Okay, so there's no burst credit allowance here that you need to be worried about or track. You basically just set your limit and go to town. That's it. Any questions about either the provisioned IOP volume or the general purpose volume as far as like sizing and math? This is, by the way, all over the exam, particularly the 3 IOPS per gigabyte allocated and the 500 per gigabyte allocated per provision and whatnot. And the maximums are there too. They'll do weird things in the exam. Well, they'll say things like, I have a database that needs 50,000 IO per second, and they'll give you the things and tell you, and it'll be like provision IOPS and GP2. And you got to know that the breakpoint for maximum IOPS on GP3, on general purpose, is 16,000. You have to know that. So just know if you're taking the exam, you at least want to know the min, the max, not the data transfer size. I don't know that I've ever seen a question on that, but you need to know the IO per gigabyte, the minimum and the max for both of these two volumes. All right, floor's open for questions. Okay. Let's talk about hard drive volume types. Is it throughput optimized or is it cold? Those are really the two different types of basically mechanical hard drives, HDD hard drives that are available to you. Here's the difference. So ST1, right, versus SC1, these are the two types. These are mechanical hard drives. They cannot be boot volumes. So you can't boot an operating system off of them. They're too slow, right? But if you're running a streaming workload like big data, data warehousing, log processing, the throughput optimized option is actually great because it's a streaming workload. So if the question says, I need a high throughput sequential like storage mechanism, then the throughput optimized is going to be your friend. If they're like, what's the cheapest disk drive to store stuff that is infrequently accessed where cost is essential, then cold is your friend. Now, just like the other volumes, these all can cap out up to 16 terabytes of volume. You can get a 16 terabyte volume of any of these four different types of hard drives. So it's not like there's a limitation there. I think the minimum is smaller. I think I want to say it's like a gig or something. It didn't matter. The max is what matters the most. The minimum doesn't really matter. That doesn't show up on the exam. But again, the distinction here is that you want to use throughput optimized if it is a sequential streaming workload that you need high throughput for versus archival storage, which is really what cold is for. That's the main thing you need to know. So these are secondary volumes that get attached to your instance, and you're going to have GP or provision IOPS on those instances. So, yeah. So remember that volumes are tied to availability zones. By the way, notice the listing right in the center of the page where it says GP2, IO1, IO2, and that little black box there. See where it says SC1, ST1, right? Those are the like code names. GP3 is not listed there, but it's probably up at the top. So I don't know why GP3 is not listed there. That's so weird. Notice the EC2 command line at the bottom to create a volume. Notice that EBS is a subservice underneath EC2, just like VPCs used to be a subservice underneath EC2. So notice that you specify the size, the availability zone, and the volume type. So, all right. Okay. Notice also that the interface will actually tell you when you're creating an EBS volume, it'll actually tell you the performance profile. Notice that under the size, it says minimum of 1 gigabyte and max of 16,384. So notice the IO profile says baseline of 3 IOPS per gigabyte with a minimum of 100, burstable up to 3,000. Notice it says throughput per megabyte is not applicable because if you were changing the volume type to say an SC1 or an ST1, you would see throughput there. Notice the option for encryption. Attaching EBS volumes. So volumes can be in various states. They can be detached, attached, right? That kind of thing. Where in relationship to EC2 volumes, EC2 instances, sorry. Notice that the device ID, you can actually specify a device ID that gets presented to Linux as a certain kind of like, letter number. Sometimes that gets converted into the operating system into XVA and various kind of like /dev formats. You can resize the volume, right? So after you modify a volume, please wait at least for a quarter of a day, so 6 hours, before you decide to try and change it again. So you can't actually like, shift a volume. just know that when you expand the volume, you actually have to go into the operating system and extend it, the file system, right? So just be aware. That can be done on the fly, by the way. There's some really great scripts out there like that can literally like extend a volume on the fly while the system is running with no impact to performance. It's really cool. Notice that from our question yesterday, right? RAID 5 and RAID 6 are not recommended for EBS because the parity write operation of those RAID modes consumes a lot of the IOPS available to your volumes. It's going to reduce performance, and it will not improve availability and redundancy over the levels that are already maintained by AWS at the hardware level. So they recommend that you use RAID 0 and RAID 1 and deploy them at the software layer. And obviously RAID 0 will double the throughput and increase the maximum IO available. And RAID 1 will obviously increase redundancy, right? So from our question yesterday, RAID 5 and RAID 6 are typically off the table. 0 and 1 only. Multi-attach we touched on before. So multi-attach basically is where you can attach a single provisioned IO volume to up to 16 Nitro-based instances. So these are special EC2 instances. They usually have an N after the number, like C6N or M5N, that kind of thing. And you can attach multiple multi-attach volumes to instances or set of instances. So just so you know, each instance is going to have full read and write permission to the shared volume. So you're going to probably need to mount it inside the file system as read only, or put a clustered file system, either GPFS, either Microsoft clustered share volumes, or a global file system. I think it's GFS2 for Linux, or something along those lines. If you expect multiple operating systems to write to a volume at the same time, you have to have a clustered file system. All right, any questions about those additional like resizing or attaching or RAID or multi-attach? Okay. All right, so let's talk about monitoring EBS volumes, right? So the first thing is that by default, AWS is going to issue health checks every 5 minutes for each of your EBS volumes. You can actually find the results just by looking at the volume and just looking at status checks. Obviously, you can pull this out in a variety of different formats. If the consistency of a volume is not a concern, and you prefer that an impaired volume, like one that is maybe like having like issues but still is available, you can actually configure it to automatically enable IO even if it's impaired, right? But I don't know anybody who really does that because everybody cares about the consistency of data. So that's just if you're troubleshooting and you got to force something to run in a partial state, you could do that. But in general, most people don't do that, right? They don't run data in an inconsistent state. So, but some people, I guess, do. In general, by the way, Amazon maintains a rule of 3 on your data. So there's actually 3 EBS volumes behind your data. So they actually maintain that multiple backup copies. You can actually lose one of your 3 disks that make up what looks to you to be a single volume, and you'll never know it. I've actually had Amazon come back to me and say, hey, we lost one of your disks, and that's why you saw a blip for 2 seconds, right? But your disk came back online. And I was like, oh, okay, well, good. I mean, that was only a 2-second little blip. That was fine, actually. No, don't get me wrong. It was enough for us to see it, but it recovered like super quickly. In general, I would say that's probably happened maybe less than a handful of times is that I see any issues with EBS volumes. Generally, it just runs invisibly behind the scenes and it runs flawlessly. Oh, so in addition to the standard health checks, provisioned IOPS basically has a performance check to compare expected with actual. So the standard health check is going to turn back okay, warning impaired, but the performance health check for these IO2, IO3 volumes are actually going to return, am I normal, am I degraded, severely graded, am I stalled, or not available? And so they mean what they say. So if it's degraded, it means there's some kind of impairment where performance is actually below the baseline. And that's only usually like, 20 or 30%. If it's severely degraded, it's well below. If it's stalled, it means it's basically just down to like a fraction of its maximum throughput or IO. And if it's not available, it means the disk is just not working. So with provisioned IOPS, you get like more granular levels of detail. Here, there's a bunch of CloudWatch metrics, by the way, since it is actually an external system that Amazon controls and can see easily. You get a bunch of things like read bytes and read ops and volume write bytes. And I mean, you get queue balance, burst balance. Burst balance is like the credit burst balance is probably one of the more important things to check if you are relying on being bursty with your performance profile. That usually only happens, by the way, with workloads that are like pretty static and then all of a sudden they spike. You can just look and see, like most of the time it follows a pretty standard convention. Okay. Any questions about CloudWatch or the performance status checks or any of that around monitoring ABS volumes? Okay. So let's talk about backups. So backups are basically known as snapshots in relation to EBS. And basically what this is snapshots provide a really low cost method of backing up data on EBS volumes. And it, oddly enough, it actually sticks it in a private section of S3 that's tied to your account that you really can't see in S3, but it's actually dumping it in S3. And you can only get to it through the snapshot section of EBS, right? So if we're in the console and we go to EC2, underneath EBS, right, you can actually go see your snapshots, right? So here's an old snapshot that was, oh, I thought that was older actually. Oh, whatever. That you can create. You can actually create lifecycle manager policies as well, and then any kind of extraneous volumes that you have, right? Notice that these are all in use. When you go to create a snapshot, it's basically going to say what volume do you want to back up, right? You can pick it out. Obviously, if the volume's not encrypted, the backup's typically not encrypted. You can add key value tags if you want to, right? You could also, by the way, grab everything off of a particular instance. So if you're like, hey, I don't really know which volume is attached to which instance, if I wanted to grab my dev on AWS volume, I could do that. If there were 5 of them, it would snapshot all of them. So it's actually pretty cool. I could copy tags from the volume if I want to, and then you just go and you create a snapshot, and then that's what it does, right? And so you can actually then go look at the snap and notice that it's in a pending state. You can actually see its progress, and you can actually pull up the detail if you want to like see like if it's encrypted, blah, 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 right? You can make snapshots private. I'm sorry, public. Obviously be careful with that. So if you want to. And so that's pretty straightforward. Now, how snapshots work is that basically they're going to copy block level data to S3. The like objects that make up that block level data, it's all redundantly stored, and basically you could sustain the loss of 2 data centers. Like I said, rule of 3. So when these backups are made, they're actually copied to 3 data centers, which is awesome for redundancy. So the first time you snap a volume, it's a full snapshot of the entire disk at the time the snapshot was taken. The cool thing is that all of the subsequent snapshots will only capture the deltas relative to the previous snapshot. So if you add data to your EBS volume after copying your first snapshot and then create a second snapshot, what will happen is that only the new blocks are then copied to Amazon S3, right? The second snapshot, by the way, will restore the volume consisting of the blocks from the first snapshot and all of the new blocks. Snapshots are based on deltas. So only the changes from the previous snapshots are going to need to be copied over to S3. Sorry. So here's snapshot 2. Notice that in the S3 bucket, we've got that delta. Notice here with snapshot 3, we've replaced some of the data. So A and B have actually changed. Those blocks have changed. And so now what's happened is that the S3 bucket now has G, H, D, E, and F, right? So only the blocks that have changed will be copied. So the new recipe will store the updated blocks, and any of the remaining blocks will still be present. So notice that it's going to basically only store the data relevant to the latest changes. So if you get rid of the other snapshots, that data will go away. If the snapshots are still there, the data is still going to be there. So literally you can point in time restore as you need to, but as you delete snapshots, data is going to disappear. Okay. Does that make sense to everybody? Anybody that's not clear to? Okay. All right, creating snapshots you saw me do earlier, right? So for example, let's say you create a snapshot. You can then copy the snapshot over if you want to push it into another region. Obviously, we saw this earlier where we were actually copying snapshots from the command line using the copy snapshot kind of EC2 call. And all you need to do is specify your source region, the source snapshot, the destination region, and then if you want to put a description on there, which is recommended, right? Now, one thing that's worth noting is that when you want to create application consistent snapshots, especially with databases, as an example, right? You can kind of create a backup that's in a crash consistent state, which is probably not what you want. So that means that important metadata that the operating system uses for directing traffic to an application to disk may not be copied during the snapshot operation. So typically what we recommend is that, if you can, take advantage of things like the volume copy service on Windows, the volume shadow copy service, I think that's what they call it, VSS. Try to like freeze and flush disk on Linux, try to like quiesce the database and then take your backup, right? So you don't necessarily have to shut down your instances or disconnect them when you need to back up all the attached volumes, but particularly with sensitive applications that are doing a lot of buffering and then write and buffering and then write, you probably need to clear the buffer and write it to disk and then take your snapshot, because otherwise you're not going to capture all the pending transactions that are in memory. So make sure that you really know, for those applications that buffer a lot of useful and meaningful data, that you understand how that functions. Because if you don't flush that buffer to disk and you take a snapshot, your application is going to be in an inconsistent state. That's not required for all applications. It's only for the ones that do sensitive buffering. Like something might accept a write, tell the client it's been written, but they haven't flushed it to disk yet. Like occasionally I see Elasticsearch do that, right? Which is probably the only data store that I maintain deep expertise in. Elasticsearch will maintain like things in buffer cache, but it hasn't been flushed to disk yet. So you kind of have to force it to flush to disk if you actually want to take a proper backup in some cases. Now, here's the cool thing. Elasticsearch is a distributed database. So literally I can just take one of the systems, quiesce it for a second, take the backup, and I get all of the cluster, right? Because it's got a copy of all the data, depending on how you set it up, right? So make sure you have some kind of methodology like that. By the way, sometimes it will require you. Oh, actually, that's for AMIs. Sorry, get my lines crossed. Restoring snapshots, which, by the way, I would argue that backups don't matter. Restores are the only thing that matter. If you are not testing your restorations, your backups are useless. So that means that, at least once a month, you should be test restoring your backups, right? Just to make sure that they're, functional, right? You can restore a snapshot to create a new EBS volume, which is kind of cool, right? So you can actually like boot up another copy of your production system just to see if it comes up. Note that it's going to ask you the same general questions around like, what's your performance profile? How big do you want the volume to be? The volume can be bigger than your snapshot. Obviously, it can't be smaller, right? Just know that volumes that are restored from snapshot have this first access latency penalty. If you want to do that, you can actually check a box, which I think you saw. If we go to create a snapshot. Oh, no, that's for restoring a snapshot. Sorry. Let it. Oh, yeah. So basically, if you want to like restore a snapshot or create a volume off of a snap, what you can do is when you go to create a volume, you can typically, oh, it's not listed here. Why is that? Oh, it's not enabled. Oh, you have to enable fast restore. That's right, on an AZ basis. I have this in my production account, but I don't have it in my demo account. So what this means is that if you have enabled fast restore capability by availability zone, right, that the volume is in, what will happen is that instead of you having to manually go in and write to every block in order to make sure that there's no access penalty, it will actually do it for you. It's a feature that they added. If you do not use fast restore and you restore a volume from a snapshot, what will happen is that the first time you access a block on that restored volume, it'll take a second for it to restore. We're only talking like milliseconds, but it will be a delay actually. And so if you want to avoid that delay penalty, you're going to need to restore your volume by writing to it first, or you can enable fast snapshot restore where Amazon will actually write the block out for you. So you don't have a performance penalty. Now there is an interesting lifecycle management for snapshots. So you can like automate the creation of snapshots. You can actually do cross-region replication. You can set your retention value. So for example, here, you can actually set the frequency of basically backups, and you can set how many or how long you want to keep the volume for, right? In other words, you might set up that I'm going to like take a snapshot of this volume daily every 12 hours, right? Starting at 9, right? And then what will happen is you can say, look, I only want to retain 5 of these at any given time, or maybe 6. That's 3 days worth, right? And you can say, look, or if it's older than 30 days, like drop it. Otherwise, just keep them for 30 days. That's it. That's all I want. So very useful, actually. And AWS backup will also like set up lifecycle policies. And I think our lab touches AWS backup, so you're going to see that. Oh, good. Hey, there's AWS backup. So AWS backup kind of extends the lifecycle policy idea for EBS volumes and for S3 and makes it so that you can back up a lot of stuff. DynamoDB, RDS instances, you can back up a lot of things with backups. What you do is you create a backup plan, and you have to create a vault as well. And all of your backups for that particular plan go in that vault. And there's like rules that you use, right? And there's application aware things that you can click, like the volume shadow copy stuff, so that you can actually and you create your own custom backup windows. Yeah. So then backup will automatically take backups for you. And then once you have your vaults, you can actually go in and look at the snaps that are inside your vault and kind of manage them as you see fit. So just remember, backups creates vaults. You create like backup plans that write snapshots into those vaults, and it's not just EBS volumes. You can do, it's not every service, but you can do a lot of services into AWS backups. Okay. Questions about backup, lifecycle policy, snapshots, how they function, any of that stuff? Okay. Okay, so let's talk about shared file system storage next. So now we're moving off of like iSCSI direct attached storage, and we're moving into over the like more higher level layer 7 kind of network storage. iSCSI is built to operate at a lower level. NFS and CIFS are obviously higher level protocols. So, and when you hear the words EFS, think NFS, because actually that's what it is. It's really just NFS version 4.1, if memory serves. And what happens is that you create a file system in EFS, and then what it does is it puts a NIC in every single availability zone, and instances can now mount that NIC as an NFS like client, right? So the file system and the VPC that you want to present to obviously have to be in the same region. You can't do it across regions. You can mount an NFS EFS file system on instances in only one VPC at a time. So the file system does have to be associated with a VPC. You do want to use an NFS version 4.1 client, such as those found in like Ubuntu or Amazon Linux or RHEL. There's something else to say there. By the way, you can actually do like cross-region snapshots of your EFS file system into another region. We talked a little bit about, like, you saw this on the questions, and this is, by the way, why the practice exam is so important. Is like, we're not going to talk about max active like performance mode. We're not going to talk about provision throughput modes. So this is why you need a little bit of extra steps in order to pass the exam, because this isn't covered really in the class at all, right? We don't talk about those two modes. Provision throughput mode is where you actually set the number of IOPS to a specific level, then causes that file system to cap out of those IOPS. The like max IO mode basically says you burst to whatever you need to. I don't mind paying for maximum performance. I don't remember what the maximum performance cap is for EFS. I want to say it's like 64,000. It might be higher than that now, but I think it's 64,000 IOPS. So now that's the Linux version. This is using NFS. This is the Windows version, right? And just to say this, FSX actually has two versions. There's the Windows version, and there's something called Luster. It's kind of confusing that they did it this way, because it would have been better if FSX was just for Windows, but there's actually two flavors of network file system available under FSX as compared to EFS, which EFS just has NFS. It's just for Linux, really. Don't get me wrong, you can get a Windows client for NFS, but this is really just for Linux. This is actually literally a Windows file server that actually is shared, right? Using SMB, NTFS, Active Directory integration. It does use DFS, so you can actually use distributed file system as well. It can be mounted under a Linux file system, so don't get me wrong, because you could use, the Samba client or some variation thereof to mount SMB. But this basically works within a single availability zone. I mean, yeah, this is just standard kind of like CIFS kind of storage. It also, by the way, dumps an elastic network interface. I want to say that they just upgraded it to actually, so it could actually be just like EFS in its multi-availability zone, but don't quote me on that. I haven't deployed this. I have deployed this in production, but I haven't tried to deploy it across multiple availability zones. It was for a while just limited to one availability zone, so it didn't have the scalability that EFS had. I think that recently changed, if memory serves. If you need high performance, by the way, this is where Luster comes in. So notice at the top, it's changed from Windows to Luster. Luster is an open source file system that basically is used for high performance computing, right? So this is machine learning. This is media processing workflows. This is different from the Windows file server. This is the Luster file system. So this is so by the way, if you hear the words POSIX compliant, POSIX compliant, they're either talking about EFS or they're talking about FSX for Luster, right? So this provides a native file system interface, and it works with, and this is mainly for Linux, although Windows, I think, can mount the Luster file system if you modify it. It provides sub-millisecond latency, can handle 100 gigabytes of data per second. Luster can also, by the way, mount S3, which is obviously not super performant because S3 is not built to be mounted on a file system, but it can, right? And so here, basically, you just mount against the Luster file system, and you've basically, just like NFS, you've got this HPC, like highly performant file system. So. Okay, so we just covered a bunch of items related to mountable storage. So let me ask you this. Let's ask a few questions. Let's kick the rest off the brain this morning. So I need a bootable hard drive for my EC2 instance. Do I use an SSD volume or do I use an HDD volume? Which of those do I have to use if I want to have a bootable hard drive?
SSD.
That's right. SSD is the only option. Good. If I need 24,000 IO per second, do I use general purpose or do I use provisioned IOPS to achieve that? 24,000 IOPS. Do I use general purpose or do I use provisioned IOPS? Yeah. So I see people putting provisioned IOPS. That's exactly right, right? I have to use a provisioned volume, not a general purpose volume, because general purpose volumes cap at 16. Okay. If someone comes in and says, look, I have a logging system, you know, where I need throughput and I want to basically be able to dump that into a disk. Do I use the cold storage or do I use the throughput optimized mechanical hard drive? In other words, do I use ST1 or do I use SC1? Yeah, the throughput optimized mechanical. Perfect. Good. All right. So Amazon asked me a question and they say, I want you to choose a disk. And they say, this is a high throughput database workload. Automatically, like typically, like most of the time, what's going to be the right volume you use for a high throughput database workload? Provisions. Yeah. Good. Good, good, good. All right. So someone tell me that for general purpose GP2 and GP3 mainly, what is the IOPS per gigabyte that I get for the general purpose workloads? How many IO do I get per gigabyte for the general purpose? Good. So typically what you get is you get 3 IO per gigabyte for general purpose. The 500 per gigabyte is actually provisioned IOPS. So I'm so glad that you remembered that. We just want to flip it so that you understand that it's 3 for general purpose and it's 500 for provisioned IOPS. So good guesses there, good statements there. Okay, last question. What is the maximum? This wasn't on the slides, by the way. What's the maximum volume size that you can create for all 4 of the different types? What did I say was the maximum volume size that you could create? Give you a hint. It's in terabytes. Yeah. Good. Good. Yes. 16 terabyte or TB-bytes, right? If you want to get technical, they refer to as TB-bytes. Good. Okay. Any questions about any of the EBS characteristics before we move on? Okay. So question, I mentioned there were 2 places that you could actually set up EBS policies for managing snapshots and whatnot. What were the 2 places? One, like to give you this one, one of them was the lifecycle plans, right? The data lifecycle management. Sybil, you got it. And the other one was backups, right? Backups was the other one. So AWS backups, which I think is in our lab. So we're going to touch it here in a second. Okay. So after the first snapshot, are the snapshots differential, incremental, or full? What do we think, right? They sound incremental, right? Isaac, answer this for me. Why did you put differential? Because you could be right. Because it's only capturing the changes, right? Yeah, good. Yeah, I mean, you're only basically the way it works. Let's set the words aside for a second. The way it works is that it's only capturing the changes, right, between the previous snapshot and the next snapshot, right? So that's it. Now, what happens to the data if you delete the original snapshot? Do you lose consistency with all the snapshots beneath it? Like if you delete snapshot 1, do you lose any data? No. Good. Just want to make sure that's clear. All right. So last question, true or false? Can you create a new volume based on a snapshot?
Yes.
Yes. Yes, you can. Right. And by the way, when you create a snapshot, you are pulling the volume out of the availability zone and you are now pulling it into a regional status, which means that you can actually create a volume in any of the availability zones from that regional snapshot. So it's actually a great way to migrate an EBS volume from one space to the next. If you need to like transfer it into availability zones, you're like, hey, we want to move our database into another thing, because you cannot transfer EBS volumes to another availability zone. Okay. All right. So let's talk about this little troubleshooting scenario. I kind of harped on this a little bit at the beginning, but all of a sudden your application is processing a workload. It takes longer than expected, and your application just suddenly tanks. What is the one thing I said you need to probably take a look at if you're using GP3 or GP2, right? What do you need to look at here? Oh yeah, look at that. Burst balance, right? Notice that your burst balance went to 0. And all of a sudden, at the same time that your burst balance like dropped to 0, look at that, like all of a sudden your throughput drops down, latency goes up. It seems pretty correlative, right? Now, how would you fix that? There's 2 ways to fix it. How would you fix it? You could do one thing to the volume and you could do another thing to the volume. What are the 2 ways in which you could fix a burst balance problem? You can increase the size to get more throughput. That's exactly right, Isaac. So then you wouldn't have to rely on burst balance. You could just increase the base throughput, right? So for example, a terabyte volume in GP3 will give you 3,000 IOPS per second, right? So that's a good baseline. If you need more to get to 16, obviously you could go to like a 6 terabyte volume, right? That will give you the 16,000 max. What's the other way that you could change that volume in order to get around the throughput issue? If it's GP3 or GP2, right? Well, you can't increase the IOPS level unless it's a provisioned IO volume, but that might be an option, Isaac, is that you could actually convert it over to provisioned IOPS, and then you would get a guaranteed, like 95 percentile, you'd get a guaranteed IO level, right? So you could actually convert it over to provisioned IOPS, like add another volume in there and migrate the data. Good. So just remember this burst balance thing when it comes to GP2, GP3, you want to pay attention to that, right? Especially if you're relying on it. If you're not relying on it, then you're fine, right? But you want to come in here and check what your like operations per second are, and you probably want to make sure that your volume is extended to meet that, so you're not relying on burst balances, right? At least like your mean, right? So just something to think about. Okay, so we just spent a lot of time talking about volumes and whatnot. And so now what we're going to do is we're going to actually roll over into a lab for archiving, backup, and recovery. So here's what we're going to do is that the first thing you're going to do is we're going to subscribe to a topic that's already created. You're going to create a backup plan, including a vault. You're going to add resources to the plan. So these are the things you're going to back up. Then you're going to enable notifications to that topic, and they're going to run some backups, and then you're going to go take a look at the CloudWatch logs to see what's going on. Okay. So in the actual space itself, if we open up the lab, and it looks like 14 labs are pre-warmed and ready. Same thing, subscribing to a topic. I wonder why they changed that. That's interesting. It no longer keeps it on the right-hand side. So you're going to subscribe to a topic, create a backup plan, exactly as stated, assign resources to the backup plan, do the on-demand backup of the volume, examine the Lambda function, which is going to actually run the tests, test the backups, and you're going to receive. You should receive an email. It can take a second, by the way, to get the email. And again, remember all the discussion around it showing up in spam and stuff like that. And they're going to review the CloudWatch logs. So there you are. Okay. All right. You should be all set. So let's go ahead and take a run at lab 5. Typically, let's see. The duration for this lab is considered to be about 45 minutes. I think they allocated 55 for this. So we're going to check back in around 11 o'clock. So let's go for it. And then go ahead and get started, hit the start button. and let's get cracking, and then we'll pick up object storage afterwards. Okay, I'm going to be here, so I'm going to stop sharing my screen, but just let me know if you have any issues. But otherwise, let's do it. Or last module before lunch. Did anybody have any questions about anything that was in that last lab that we just did? No? Okay. I know that there was a longer delay than expected, especially from the instructions. So it looks like it took about 20 minutes in some cases for jobs to trigger, maybe even a little longer. So it was good to know. Okay. Let's switch off then of mountable storage, and let's move on to object storage. And there's no lab associated with this object storage, but just to mention this, when we were talking earlier about quick labs, see here, just know that there are a ridiculous number of S3 labs out here. So if you're looking for S3 labs, remember, if you create your own bah.com login into amazon.quicklabs.com, not WebAge, but amazon.quicklabs.com. Remember, you can get access as a Booz employee to a number of hands-on labs. They've got, a bunch of stuff out here. I think, oh, it is still out here, actually. It's no longer free. There's, a number of really great options. So, like I said, a bunch for S3. And by the way, that's only 10 per page. One thing to be aware of is that they will cap at 10 labs per page. So frequently you have to upload it to 25 or 50 to see actually everything that involves S3. Almost every lab actually out here on Quick Labs does have some S3 sourcing or something, but usually it's set up for you. You don't actually manipulate it. But there are at least 10 labs that focus just exclusively on S3. All right. So that being said, let's talk about S3. Let's dive into it. So we're really just going to talk about S3. We're going to talk about aspects of S3, layering of S3. I think Glacier is included in this as well, if I remember correctly. And then we are going to talk about storage lifecycles. So this is us about optimizing data storage, especially for like a large swath of files that don't necessarily need intensive IO. How to back up data, because S3 is one of the best places to just dump data because it's cheap storage, right? And then if you set up a data lifecycle classification plan, it becomes even cheaper, because if you're really not using it, then you can actually just have it automatically rotated to a colder tier of storage. I can tell you, especially I work a lot with data scientists and machine learning folks, and they're like, do you really need that behavioral click data from like 7 years ago? And they're like, yes. And I'm like, why? How's that relevant for the business? And they're just like, just keep it. And I'm like, okay, as long as you can get business justification, which they usually do, you usually keep that data, but it might not be looked at for years, right? It just depends on what's going on at the time. That's a great candidate for archival storage, right? So just know we're going to talk about some of those facets. Now, the main thing that we're interested here is like everything from S3 over, right? So that's really what we're going to focus on. The rest of this we just talked about with EBS and EFS and FSX, right? We already had a conversation about that. Now, S3 is fast, durable, scalable, fully managed object storage. It also has, there's an archival object storage as well as an infrequently accessed object storage. There's standard object storage, but basically you got a client. It does not mount the file system unless it's Lustre, which it could, but it's still horribly slow. But basically, this allows you to request objects, use the objects, retrieve the objects. And that's really the focus, is that you got a client, they either put an entire object or grab a portion of an object, or they pull up, an object or a portion of an object. And you might say, well, Michael, how can you put a portion of an object? If you're doing multi-part uploads, you can actually just break it into like pieces. And as you put each piece up there, eventually S3 will assemble the file. So if you have like a 5 terabyte file, you have to break it up into what they call multi-part uploads. And so it'll break up into chunks, and then it'll parallelize. And then, once all the pieces are there, S3 will actually assemble it and stick it into a bucket. Now, when you put stuff into S3, files, images, video files, log files, doesn't matter. You can put anything you can put on a file system, you can put into S3. The only limit is the file size, 5 terabytes for S3, 20 terabytes for Glacier. Objects are automatically replicated across all the availability zones. So this is a regional service. It is managed at the global level, but it exists at the region level. So you actually have to say where you want your home base for an S3 bucket, where you want it to live. And you can enable replication within the same region or cross region. If you enable cross region replication, you can actually copy, say, from Virginia to Ohio. But, other than the lag that shows up, you can actually, engage it anywhere. In other words, you can put your cross region copy to any other region in the world, right? S3, so I don't know if you see this show up in the news a lot, but S3 shows up as like, once again, Capital One exposed, 5 million credit card thing in the data breach, blah, blah, blah. And it's like, you might think that to yourself, oh, that must be AWS's issue, right? And in a sense, it's definitely their issue, but it's not their problem. What ends up happening is that, Amazon makes it really hard for you to share your bucket publicly. They give you all kind of warnings and check-ins and all this other stuff. People still do it. This is one of the access points that you have to overcome in order to make your bucket public. There's actually a separate block public access, like toggle switch, that you have to hit in order to enable public access. So, this is set both at an account level and at an individual bucket level. So you can actually force it to be closed. You can force your account to be closed so that no one can share their bucket. This is a section inside of S3. If you flip the switch up, you still actually have to go into the access control list and or the bucket policy and specify that you are making your bucket available. But this has to be overcome first. If you do not switch this toggle, you will not be able to make your bucket public. Notice that you have a bunch of options. You don't just have to give everybody public access. You can give them new access, any access, new or any access around bucket policy or access point policies. So you can control whether you use access control lists or bucket policies to grant access. So you've been told. Now there is an access analyzer, not just for IAM. There's also one for S3 that will tell you whether or not someone can access an example bucket, right? And this includes third-party accounts. So it basically alerts you to S3 buckets that allow access to anyone on the internet or other AWS accounts, right? That's what it does. And it'll show you the type of permissions they have, whether it's read, list, write, etc. You can turn on access logs, by the way, for your buckets. It will then provide detailed records. Now, just to switch gears for a second, if I go over to the management console and I actually go over to S3, which we've been here before, just note that I have a bunch of like links here, right? Sorry, buckets here. If I click on BAH admins, just note that this bucket has a URL. And so like if I wanted to share the simple greeting.zip, if this was a public bucket, you could actually paste this into a browser and someone could get to it. Now, right now, should we paste and go? This bucket is actually open, right? So I actually just downloaded that simple greeting.zip zip file. So just note that anything in here, if the whole bucket is public, is going to be available, but you do actually have to know the pathing. So it's not like, you can just like list the entire thing. Notice that here's an EC2 directory. Here's a static web. In other words, everything in here, every object that you stick in S3 ends up with a URL. Whether or not someone can get to that URL depends on your permissions. So just because you enabling a URL for every single object doesn't mean anybody can get to it. It just means it's an option, right? So, oops, I did not mean to open that. Let's see here. So you've got an S3 bucket, you've put stuff in there. Maybe you've disabled public access or enabled public access. Let's say you wanted a more detailed logging, right? you can basically enable server access logging, and it's going to be, it's basically going to allow you to audit everything around access. Who's doing it? What are they doing? How are they accessing things? Think of these as like web server logs for objects that you have inside your S3 bucket, right? So this can be very useful if you need understanding about how clients are using your objects. Now, there's another product here inside of S3 called inventory, and it will actually automatically generate reports about the details and the contents and the status of objects inside of an S3 bucket. So you can use this to audit and report on replication, encryption status, especially for compliance and regulatory needs. So inventory is another sub aspect of S3. Hello. You can also, by the way, check event notification for almost any event that you can do inside of S3. The reason this is significant is that this is a little bit like CloudWatch events, and that it will go and trigger other things. Like you can dump information onto an SQS queue, you can dump it into an SNS topic, you can actually dump it into a Lambda function, right? So for example, if replication is failing or an object is deleted, you might want that to go to an SNS topic that then notifies some admins and says, hey, someone just deleted an object. Is that what you wanted? So you can specify a bunch of targets. Just to say this, once it gets to Lambda, it can pretty much go anywhere because Lambda can make any API call you need. So you can actually submit the information over to any other service at that point in time. So in addition to having event-driven notification, you can actually turn on versioning with S3 as well. What this does, though, just so you're forewarned, is that if you turn versioning on inside of a bucket and you've got a gig video file and you go in and you change the metadata on that gig file, you now have 2 gigs worth of files. You've got version 1, which has no metadata on it. You've got version 2 where you change the metadata. So be careful with this. So I actually had somebody turn on versioning on a video file bucket that had thousands of video files on it. We were in there programmatically changing metadata and stuff. Next thing you know, we've got 2 to 3 times the size being charged to us because versioning was enabled and we were making metadata changes and we hadn't really accounted for that when someone turned the bucket on. Just know that deletion is just another version of the file. So you can actually still retrieve the older versions. You're not truly deleting the file when versioning is enabled. If versioning is enabled and you delete a file, I'm sorry, if versioning is disabled or not enabled and you're deleting a file, that file is truly deleted. So just keep that in your back pocket. Turning on versioning is a great way to prevent accidental deletion because you can just go back and grab the previous version. You can also, both with Glacier and with S3, you can enable what they call lock modes, right? And there's 2 modes. There's compliance and governance. Oh, actually, it says it right there. There's compliance and governance mode. So with both modes, it's interesting because with compliance mode, you cannot change the file. Not even the root account can change it. Basically, it basically locks it down. So this is a great way for auditors to see your compliance, like evidence or forensics evidence, and nobody can touch it. Nobody. Governance mode can have a time period, but the retention mode cannot be changed. The retention period cannot be shortened, but you can change. It's a protected object version that cannot be replace that. Basically, what it is that in governance mode you can protect deletion by most users. But there are specific people who can actually do some things to the retention settings or delete the object if necessary. So governance mode has a little bit more flexibility. Compliance mode, the object is totally locked. You can't really do anything. All right. Let's talk about the different tiers because we just talked about versioning and inventory and object locking. We talked about the different aspects of S3. Let's talk about the different flavors of S3 for just a moment. So these are all the flavors of S3. Notice that with the exception of one zone infrequent access, all of them are multi-AZ protected. Oddly enough, in the documentation, at least, they haven't really changed the numbers for like durability for one zone IA, which is a little strange. The only one that doesn't really govern around the dimensions of storage size and a number of changes that you make to the object is the intelligent tiering. Intelligent tiering is interesting because intelligent tiering actually moves your object to all of the other tiers depending on your access pattern. So if you access it a lot, intelligent tiering will move it into standard. If you don't access it at all, it'll move it into deep archive. So notice the line where it says frequent over to the left and infrequent over to the right. Notice also that once you get past hot S3 and intelligent tiering, you're going to be charged per gigabyte retrieval fees. That's going to be tiny, right? But if you're retrieving terabytes and petabytes of data, it's going to get costly. You have per gigabyte retrieval fees for retrieving infrequently accessed or cold data. That's what the IA, by the way, stands for. Is this? It says S3 standard dash IA. That's infrequent access. So just know that these are the hot to cold storage classes. Now, Glacier has no direct accessibility. That means that when you move a file into Glacier, you cannot actually access it in any way, shape, or form until it's restored. So think of that as truly like an archive vault. One zone infrequent access, standard infrequent access, intelligent tiering, and standard S3 are all accessible storage. Now, obviously, standard and intelligent tiering, you can access things hot. With infrequent access, it actually means that you should be infrequently accessing it. If you start accessing it as if it's hot storage, you're going to start paying for that access, which is why there's a per gigabyte retrieval fee with IA, even though it's accessible storage. By the way, you can create lifecycle policies that move your objects through all these phases so you can get from hotter to colder storage. Say like after 30 days, you can go to infrequent access. After another 30 days, you can go to Glacier. After 90 days, you can go to deep archive, right? You can create the policy that you need. Again, just to mention this, intelligent tiering actually moves you between the other tiers. So, don't get too hung up. It's more of a storage management class than it is a storage class. Now, lifecycle policies can rotate through any of the different objects. So remember that you can create data lifecycle policies for S3 that do things like set the target, select an action. So after a time period or apply to all objects or some of the objects in the bucket, you can actually copy, transition things to other like versions of storage. Now, Glacier is a slightly different beast because I have been mentioning it as archival storage. You can actually either use lifecycle rules, directly put it in from an API, or archive using an API. Typically, people stick objects into S3 and then transition them into Glacier. Glacier stores data a little differently than S3 because once it's put into a vault, it is not directly accessible. You have to pull it out of the vault, which restores it to S3 if you actually want to use it. You're limited by some weird high numbers, like you can have 1,000 vaults in Glacier. I don't know that anyone's ever run into that number. Again, interacting with Glacier is either through the lifecycle policies where you transition from S3 out, or you can actually directly dump things into Glacier using the API, right? If you want to retrieve things, this is where things get interesting. Standard retrieval time is going to be 3 to 5 hours before your job even starts, right? So to rephrase that, it can start and complete in that time period, right? This is the default option. Restoring an object can take 3 to 5 hours. Obviously, it's a 20 terabyte object. It could take a little bit longer. If you have a bunch of objects to get, you can actually do a bulk retrieval. It will usually take a day. It can be petabytes, by the way. Bulk retrievals usually, finish within 5 to 12 hours. Obviously, the more data you have, the more likely it's to be above that. Expedited retrieval is you're basically saying, well, you know what? I made a mistake. Someone suddenly needs it. We need it now. Let's go. And you pay a small fee And by the way, there's two types of expedited retrievals. You can do on demand, which you just pay the full fee, or provisioned, where you've like, you've like bought like the ability to at a cheaper price. You've bought the provisioned expedited, and that takes 1 to 5 minutes, and it literally just prioritizes your restore, restores it, dumps it into S3, and now you're good to go, right? So restoration, this shows up on the exam, by the way. They'll say, I need to restore a Glacier object within, 15 minutes. And you know that you're going to need to use expedited. If it says 3 to 5 hours, you use standard 5 to 12 hours bulk. So let me ask you this. Why would you actually use a colder tier of storage? What does that get you? Someone tell me why we would even think about using a colder tier of storage. Yep, David, cheaper is definitely a factor. Compliance is definitely another factor, Wesley, especially if you need object locking, right? Yeah, cost versus access, good. Yeah, good. So, I mean, you use the hotter storage because you need the performance, use the colder storage because you need to save money, right? Now, if you don't know your access pattern because it varies or goes all over the place, or you're just not sure, some people will actually start with intelligent tiering, and it will teach you exactly, which objects are going to be hot and which objects are going to be cold. So if there's a varied access pattern, intelligent tiering is probably your friend. Good. All right. Now, if you wanted to set up lifecycle policies, you can. The other thing is that I wanted to actually show you this. Signer, that must be a new thing. All right, let's say we create a backup plan. We're going to build a new plan from scratch. We use defaults, transition and cold storage, copy to destination, advanced backup settings. So all right, so we got a backup plan, right? We're calling it S3, and we've added a backup rule, and then we can assign resources. So the real question is that, obviously we can do this by like assign resources by tag. There's a bunch of different options here. And, the question is that you can do this, like you can do some S3 management here inside the backup plan. Obviously, if you're inside of S3, you can also do that within, setting up the lifecycle policy. So if we go to the particular bucket, let's say we choose BAH admins, right? We can actually under management, but I'm just checking out version just to make sure that's done. Okay, good. We go under management, you can actually create lifecycle rules here where you're basically saying, hey, let's say it's like 30 days to infrequent access, right? You can basically apply lifecycle rules that transitions versions to a particular tier of storage, right? It just depends. And in this case, I want to do it to all objects into a bucket. I can, do all kinds of rule actions. So just know that there's two places. Most people do the S3 buckets independent from the backup plan. But you can actually use that to transition and then snap and back up your data in the backup plan as well. All right. Was there something else to show there? Good. All right, so that's mainly the pieces around S3. Oh, the other thing I wanted to show you, hold on. That's right, the AWS simple monthly calculator. Let's see. So if we look at the simple monthly calculator, which AWS is actually trying to retire, but they can't because people love it so much. I just wanted to show you like some distinctions here. So let's say that we do a terabyte and let's say we don't like do a whole lot of requests, right? Let's say that we're in the free tier as far as our modifications go of an object. If we have a terabyte of data inside of S3, it's going to cost you $23, assuming that you're not doing whole lot of writes and modifications, right? Now, if we go down to intelligent tiering and we do a terabyte, and let's say we're within whatever, like free tier or whatever, right? Notice that it's just slightly more, but honestly, just to say this, it really depends on the percentage of storage not accessed changed. Intelligent tiering is harder to scope, but it's a little bit more, usually about 10% more than standard tier, right? Now, let's say that we come down to infrequent access and we do a terabyte and we're still within the free tier. So same access pattern, right? Notice that the price is pretty much gone to 50%, right? So infrequent access without changing redundancy is now down to about 50% of what it was. So instead of being 23 and change, it's now $12. Let's go down to one zone and let's change it to terabyte. And then notice that instead of going down to 50%, it's like 45, 40, something like that, right? So it's gone down a little bit more. Now, this is all accessible storage. If we come down to Glacier, and let's say we take those same files and we put them into Glacier and we leave them alone, notice that our price just went down to $4.10, right? Again, minimal access patterns at this point in time, $4.10. And I think you have to leave it for 60 or 90 days there if you wanted to use Glacier. Let's say instead, we all go all the way down to the 180-day deep archive. So instead of being $23, what happened basically? It went to basically 1/24 of its cost. It's now $1. Now again, Glacier and Glacier Deep Archive are not directly accessible storage, but it's to show you why people create these lifecycle policies and roll things into Glacier that they need to retain because you're paying 1/25th, or 1/20th of the cost. Hopefully that was useful to people to see. So that's the cost differential, typically. Now, again, that can change greatly depending on what kind of changes and writes and puts you're making to the files. And it could change greatly if you're having to retrieve the file a lot out of the Glacier section. So just know, particularly when you get to infrequent access, it needs to truly be reduced infrequent access. If you're treating infrequent access like standard S3, it's going to start costing you like standard S3 and probably a little bit more, honestly. Good. Oh, one other thing I wanted to show you, because I think I mentioned this earlier, but I didn't actually show you the difference. Okay, so let's say we've got 1 terabyte of storage over here, and that costs us $23 a month. If I switch this to Northern California, the price here actually doesn't change, right? It's about the same, right, price. Oops, hold on. So for things like highly managed services, the price difference for California might not actually be super evident, right? But let me show you this just for California. It's not S3 that's the challenge here. If we switch over to EC2, and let's say I decide to do a T3 2X large, that's going to cost me $243 a month for that instance. If I switch over, if I remove this actually, so that's $243. If I switch over to Northern California and I add the same thing, right? Look at the price difference. So what you see here is that for the highly managed services, you won't see a price difference per se between like S3 and DynamoDB and whatnot. But for things that require footprint like EC2, you'll see a big price difference between like US West, like Northern California, compared to all of the other regions that are on the North American continent. I just wanted to show you that price differential because it's not insubstantial. It's $243, and that went up basically $47 up to right $290. So just be aware that most people avoid Northern California. If we do this same thing and we switch it, let me take this off. And let's say we go over to Sydney, for example. And I go into Sydney, I do the same thing, and I do a 2.3x large, and we're curious about the cost. It's $309, right? If I take this off and I switch over to Tokyo, so $309, and I switch over to Tokyo, and I do the same thing, I just add the same box. notice that it only goes up by about $9. So that's not necessarily substantial. That's actually a smaller price differential than it's shown in the past. So they must be getting more efficient at the footprint in Tokyo. Previously, it's been 10%, usually more, which is, a significant chunk of change, but it is slightly more expensive. So at least they're normalizing that. They don't seem to want to do that with Northern California. So Northern California seems like it's going to be retired at some point in time, or at least downgraded. Okay. So again, just wanted to highlight the difference between US West 1 and everybody else in North America. Okay, good. Any questions of any type about S3 costing, anything that we just talked about, cold storage versus, archival storage versus hot storage, any pieces there? Okay. So I'm going to go ahead and start costing and billing. And then we're gonna just stop kind of like just a little bit before noon, right? Just because honestly, we have the time. So. And I'm not going to pre-warn the labs because we're going to come back and work on the rest of this afterwards. Okay. So just know that we have our capstone lab next. And then what I'm going to do is I'm going to go through all the training information. Then I'm going to give you the course evaluation, and then I'm going to close out the course. Wait, is that right? Yeah, that's right. So, so I'm going to give you all of your training information. I'm just going to review it, and then you're going to get an email from me with the playlist plus all the training information. You obviously have seen the study guide, which we're also going to talk about. So I'm going to talk about the resources that got sent to you through that email as well. A lot of this we've covered already. And, we'll spend some time before we dive into that, kind of like doing a review of the questions yet once again. It looks like kind of where we're at right now is that, technically the official content of the class will probably be done around 3 or 3:30, right? We can spend some time reviewing whatever you want to at that point in time, or I can give you your time back, which is probably the most valuable commodity, right? Not that we have to give time back. I'm more than glad to stay until 5, but I just want to make sure. I will also check in as people stop responding and, things like brains start dying. I will also check in and make sure. Otherwise, we're going to go right until 5 o'clock. Okay. All right. So let's dive into this a little bit. Okay. So we're going to talk now about just great, general cost awareness inside of AWS, some, cost control mechanisms like budgets and whatnot, and how to optimize for usage. And then, obviously we were not going to get through all this now, but then we'll start talking about capstone labs and whatnot. Okay, so how do we gain cost awareness? How do we use cost control mechanisms? How do we optimize spend and usage? So awareness wise, we want to be very aware of our current, our historical, and future, right? In other words, we want the past, we want the present, we want the future, right? And so how do we track all that? And then we want control mechanisms that will help us both detect and notify us when things start going awry. And I will tell you that from a control mechanism standpoint, we also want some hard limits. Amazon has traditionally been reticent about putting hard limits into systems, but we're starting to see that now with cost control, they're starting to actually put some limits in. And of course, optimizing cost and usage is a huge piece as well. This is where things like compute optimizer, using reserved instances and savings plans are incredibly important. So let's talk about these different pieces. Okay, so first, billing and cost management. So, if we go to the console for just a second, one of the quickest ways to actually get into this kind of thing is just to click up here and go to My Billing Dashboard. So click your name, click on My Billing Dashboard, and it automatically puts you into a billing and cost management dashboard at this point in time. From here, you can get to budgets, cost explorer, cost and usage reports, and you've got all of these options over on the left-hand side, including billing preferences, methods, that kind of thing. Now, I will tell you the bill details. Actually, let me go back to that for a second. See how it says bill details up here on the right-hand side? If I click on that and I go to August, you'll notice that, well, I didn't hardly spend anything, which is a little strange, isn't it? Because I do have things running. You saw me I have virtual machines running. So let's go check Elastic Compute Cloud. notice that there, I got charged, $10 basically for running it. Some of that was free tier. A lot of it was also just the fact that it has a trainer with Amazon. I have credits, right? They just give me credits. But notice I left that machine running all month. I don't even know. I think I used it for a few things. It's a T3 micro, right? But all of your details by region can actually be found in your bill. Now, I'm just going to tell you, they have taken great strides to improve this. This has been horrible in the past where you couldn't even figure out where things were running, but now you can. By the way, there obviously are a few things that, are, no region. In this case, it's a credit, right? But you can actually break this down and find out like where the load balancers are running. Oh, I have a classic load balancer. I don't even know what to say to that. Why would I be running a classic load balancer? I don't know. Now I got to go check that out. It must have been something I kicked up on CloudFormation. Anyway, you can see a bunch of billing detail here. So I don't want to discount the fact that the bill actually is very detailed. If you download a CSV, right, it gives you an exquisite amount of detail. I don't know why you opened over there. Like exquisite, right? This is going to break down everything that you want to see by product, by usage quota. It's going to give you a lot. Now, there are a number of services out there that will help you manage your bill on AWS. I think VMware bought Cloud Health. There's Cloud9. There's tons out there. Probably the best, just to say this, is that if you ever get in a bind and you want a real pro to look at your bill, there's the Duck Bill group, which publishes Last Week in AWS. And if you're not a member of Last Week of AWS, it is some of the most informative and snarkiest AWS information you ever get. He actually just published his second blog about 17 more ways to run containers on AWS. Anyway, it's a gentleman named Corey Quinn who heads that group. Fun guy, but also super informative, kind of declares himself as the unofficial marketing head of AWS, but he keeps it real. He'll tell you what's cool about AWS. He'll tell you what the challenges are. But if you ever get into a bind with your bill and you need a professional to really look at it, someone who's incredibly sharp, knows exactly where the pitfalls are to help you unravel it, talk to him. By the way, he's also a great guy to talk to if you happen to run a personal bill and it's you make a mistake and somehow you end up with a couple $100s or whatever. You can just Twitter him, send him a tweet, and he will actually help you figure out how to navigate your bill. Just so you know, if that ever happens and you talk to Amazon and you've labeled any of your resources test, Amazon will forgive any excessive credits that you've put on your system. They've been very consistent about that because they get a lot of flack for not putting guardrails in for playing with their services, right? So kind of a little digression there, but I wanted you to know that. So billing and cost management is going to provide tons of useful tools, including budgets, budget reports, saving plans, cost and usage reports. You may remember cost and usage reports because I was like, hey, what is the CUR on the command line, right? Because we were on the command line and I was like, huh, what is CUR? Right? Because I was like, huh, what is that thing? And it turns out that that's the cost and usage report, which you can actually describe reports and modify a report. So that's the cost and usage reports here. Obviously, tagging is extremely important for this to actually function. You need cost allocation tags in order to bill along or understand reports along the dimensions that you're talking about. So there's a bunch of really great services here. Now, this is all under that billing section that we were just on the console, right? Cost Explorer, budgets, budget reports, savings plans. Right? Cost Explorer, by the way, will allow you to break down spend by service, by month, by view, right? So notice here, we're actually in cost management. You can do cost anomaly detection if someone goes off the reservation. There can be right sizing recommendations like, hey, you've got 1,000 instances and 100 of them are under 4% utilized. Maybe you should downsize to a different instance. There is so much here, right? There's savings plans pieces, there's reservations, which, by the way, reservations is just a licensing type that you can purchase from Amazon to get deep discounts in exchange for your commitment to pay for a resource for a period of time, either 1 or 3 years. By the way, there are reservations for more than just EC2 instances. You can get them for CloudFront, you can get them for DynamoDB and RDS. So, if you don't have access to your rep, find out who has access to your AWS rep because especially if you're like, hey, we're about to do this, this, and this, just to say this, with booze, you typically have an enterprise agreement, but just know if you're dealing with other clients, you can always talk to the rep and see if they can offer some insight on reservations. So current spend is probably going to be on the dashboard. If you need to forecast, this, by the way, comes up in the exam. If you need to forecast and you have historical data on your account, Cost Explorer is going to be your friend. If you do not have historical data, you cannot use Cost Explorer. You have to use the simple monthly calculator, which was the thing we were just looking at, to get an estimate, right, on what you're going to spend. Cost Explorer only works really well for forecasting when you have historical data with it. Otherwise, talk to your AWS rep, which is, by the way, an answer on the exam, or use the simple monthly calculator to forecast, because you're estimating at that point. You're not going off of historical data. Budgeting allows you to set limits, budget limits, and it will notify you if you cross those limits, which is awesome. And then, you can actually get budget reports to see how you're doing. I think I have a couple of budgets set. Let's go take a look. Because I get notifications. So like I have containers, data stores, DNS charges. I have like limits because I'll get notifications if I cross my limit, right? Notice my EC2 budget is $30 a month because this is my demo account, right? Notice that it is forecasting based on historical trends and it's well underneath my $100, right? And don't get me wrong, I rarely spend above $100 for my demo account. My production account is a couple $100 a month, right? So notice that all the thresholds are currently okay. So like I can come in here and create a budget. Let's say it can be a reservation budget, so because I want to track licenses. It could be a savings plan budget. It could be a usage budget or a cost budget, which is typically what they recommend. And then if it's a cost budget, I just set the budget amount. And so I can say, hey, this is going to expire after a period of time, or this is reoccurring, so let's just keep it. And then, by the way, you might have to specify a monthly budget amount by month, or you can just create it fixed. So let's say I don't want to spend more than $20 a month, and I can scope it, right? If I want to specific things, it could be unblended costs, be the budget name. Now, the one thing I'm missing here, this seems to have changed. Hold on one second. Yeah, that's totals. I got that unblended. Oh, let's add a filter. So what you can do is you can add a filter by service, right? And so let's say I only want S3 because that's actually what this is for. I can just put S3 in, apply the filter, and then it's only going to do this against S3 options, right? The simple storage service. You just say S3 limit $20. And I can add an alert there, by the way, which I didn't. I just left that alone, right? Oh, let's see. Let's add an alert threshold. Let's say this. So 80% of budget. That's good. Let's do that. Let's add an SNS alert. Do I want to do that? You know what? Actually, I'm going to leave that alone. Oh, I should fill in 80. There we go. Cool. And then I can add an action. So for example, I could add a particular role, add the action in question, and add a second action if I want to, right? So this way you can actually create these particular budgets. So if like we look at this one, if I want to go edit it, notice it's got a budget amount, it's a recurring budget. I started in June. There's my budget amount. Here's my unblended cost thus far. I do have a filter for ECS. Here's my aggregated cost. Here's my details. And then my alert threshold is 80%. And then here's my notification preferences. I actually have it set to email me at IT Amazonian if anything happens. I could actually make this an SNS topic and get a bunch of people to subscribe to it. And then it goes to a distribution list if I want to do that as well. And then that way they would, like, everybody who needs to see it would actually get alerts on it. One thing I recommend is if you create your own personal account, the first thing you should do is you should come in here and create an overall budget. You want to know the minute you've left something on. I have never in 10 years of usage ever hurt myself using AWS, but that's because I'm very mindful about different accounts leaving things running. So you want to make sure you pay attention if something is running and it needs to be off, you need to set a budget alert so that you know that money-wise you're trending off of that. And notice I have very specific things that have like typically been something to remember in the past, right? Something to pay attention to. Obviously, bills I showed you just now, so you can actually click into bills and still all the billing detail. The cost and usage reports are probably the most comprehensive reporting that you can get, right? So something to just be aware of. Cost and usage reports and like that detailed customization, this is how things basically go from least detailed to most detailed. So the billing dashboard is the least, invoices are the next detailed, Cost Explorer is the next detailed, but the cost and usage report is a deep, detailed document. So again, just a reminder, you just saw the billing dashboard, and for September, I didn't have any charges yet because I have, other than the EC2 instance, there's nothing really running, right? So this gives you kind of just an initial view of like the overall health. So this gives you the now. When you look at bills, especially if you look at past ones, it starts giving you a breakdown by service. And by the way, you can actually look at all previous days' bills, so you can actually figure that out pretty easily. And then Cost Explorer basically starts to allow you to get a little bit more granular, a little bit more detail, and you can filter by account, you can figure by service, you can do usage type, you can do services, and you can do a range, right? You can do everything year to date, you can do 3 months, you can do quarter, etc. If it has historical data, it will give you a forecast if you trend and if you set your date range to the future. Right, so there's tons of options here. Again, if you forecast by adding +1 month or +3 months, it'll do this. Remember, forecasting only works if you have past historical data. If you need to get an estimate or forecast against a new project where you have no historical data, you must use a calculator or talk to your AWS rep, okay? Notice the 80% prediction interval. And last but not least, because we talked about the dashboard, we talked about the bill itself, we talked about the Cost Explorer, is the cost and usage report. This is by far the most detailed report you can get. This can then get dumped into a reports bucket. And then you can either pick up the CSV file it generates, or you can just use any of the tools to actually talk to the bucket and, you know, get the level of detail that you want. I do want to mention is that most third-party tools are going to want you to enable cost and usage reports, and they're going to want you to grant access to their bucket. So something to be mindful of. If you use a third-party tool, it's going to want to talk to your bucket that has the cost and usage report in it. The report does contain details about your account information, product attributes, pricing, and it will contain your tags. So make sure it's okay to share that. You can automate these queries like by basically, you know, having a CloudWatch event, like it could be scheduled, for example, first of the month, second of the month, triggers a Lambda, which then, you know, loads a report into Athena, which then, you know, all of that gets processed and they can email you out. There are a lot of third parties that can do this. Just know that in the well-architected labs, let's go take a look at this because I think you would enjoy this tremendously. And one of the resources I'm going to give you, this is an optional one. There's a website called Well Architected Labs. And if you're an architect, this is a great site. Even if you're not an architect and you just want to get hands-on, it's a great site. If we go under cost optimizations, it should be a 300 level lab. Hold on. Here it is. Yeah, automated query and email delivery. You can literally set this up in your account. Like you can actually set up that exact diagram that you just saw. And you just have to follow like creating the bucket policy, and you can just start the lab and it will allow you to walk step by step through creating this whole thing. So it does it manually. So it doesn't necessarily like use like CloudFormation or Pulumi or CDK to do this, but it's a great way to get very familiar with how to modify this kind of stuff in the console, right? And it will provide the JSON for you for like policy documents and stuff. So you don't have to write that yourself. Totally worth looking at to see how this works. I'm going to paste this into chat so you can have it. But if that's something you'd like to add to your account, oh, actually, David just asked me. Sorry, David, didn't see that. Yeah, so that way you can get access to it. But this well-architected labs link is full of so many good hands-on labs that if you did all of these, you would be an amazing architect, even without taking the class, right? Be an amazing architect. So this covers all the different pillars of operational excellence, security, reliability, blah, blah. These are fairly well maintained. I can't guarantee that all of these will work. It's just so much information. There isn't a dedicated person at AWS who maintains this, but they try to stay current. So just your mileage may vary, but 90% of these work consistently. So yeah. Okay. So you can literally make this dream a reality. Okay. All right. So that just covered basically dashboards, the billing detail itself, Cost Explorer, and the cost and usage report. It's a lot. Okay. So let's talk about some control mechanisms. So anomaly detection, which I referred to before because we were seeing all the things on the left-hand side, CloudWatch alarms and budgets are your detection mechanisms. Now, budgets we just talked about. So you basically just set your budget up. You set the percentage that you want to be notified on. By the way, you can set other tiers if you want 75% versus 80 or whatever. You can do that. It's not a problem. It will show you current versus budgeted versus forecasted, which is awesome. We walked through creating a budget, right? So we went through all this already, whether it's a recurring or expiring budget. Is it fixed? Do you have to plan on a month-to-month basis? You can set additional parameters, like you can set filters to filter by service. So we saw some of this already. Then you actually set your thresholds. Now, actual versus forecasted, be careful with forecasted. Amazon doesn't always get the forecasted right. You can do a chatbot. You could call a Lambda service. You can do all kinds of stuff, right? I usually just set it to an email recipient and go to 10. So that was budgets. Billing alarms, right? First of all, billing alarms only exist in US East 1, so just know all of your billing metric data is typically stored in Virginia. So if you were going to pull the Fight Club thing and blow up, something that had all relevant information, maybe Virginia would be that site. No, I'm just kidding. I'm not advocating violence in any way, shape, or form. That was just a joke. So if you create a billing alarm at a time when your charges are already exceeding threshold, just know if you create an alarm for something that's already above the alarm, it's going to go into the alarm state immediately, right? So you can just enable billing alerts. You can just enable billing alerts, right, before you create the alarms, and it basically will just, it takes about 15 minutes, by the way, before you can see all this data. But when the billing alert feature is enabled, you can basically start creating alarms. So you can manage your billing alerts, or you can try budgets. I got to tell you, between the two, I think I would probably go for budgets because it seems to be the more advanced feature. Billing alerts have been around for a while, but I think the budgets feature is way stronger. All right, so that's all detection. And to go back to our original options, right? It was anomaly detection, which wasn't even talked about. So let's dive into that for just a second. Interesting. Where was anomaly detection? Now we've lost it. Where is it? Oh, that's right. Under cost management. There we go. Where are you? How did you get away from me? Bear with me as I fumble around, because that is a relatively new thing and I don't see it now. Let's go into Cost Explorer. No, let's actually go into Cost Explorer because it should be over here. Here it is. Okay, good. All right. So here, by the way, you can just like create a cost monitor, right? Show me around a little bit. So the cost anomaly detection summaries, by the way, is going to like show you the anomalies that it's detected. It's going to show you the total spend as well as the cost impact. And what is the change? In other words, what did it see that it was like, hey, this is an anomaly? You just went up by 10%, 15%, whatnot, right? And then what happens next is it's going to show you the history of all the anomalies that it's made. And you can actually see also the cost monitors, right? You can create a monitor, obviously. So if you want to create a monitor, you can actually do it by services against linked account. You can do it against tagging, right? If you have a cost allocation tag, or you can do it against cost category. There's a bunch of different options for this whole thing. And so, for example, here we could choose our particular monitor type. Let's say we went by linked account, but let's say, or AWS service. Let's say that we were sticking with S3, right? I'm looking for anomalies. You can create a new exception and choose an existing subscription, whatever you want to do there. And let's call it, S3 costing. Specify the spend amount where you would like to start to receive alerts. I think before we were looking at $20, right? Daily summaries, and then you just put in your thing. Actually, do I want daily summaries? I think I might go to weekly actually on that. And then create a monitor. And if it detects any deviations, it's going to send you an email. Basically say, hey, I detected an anomaly. All of a sudden you're spending this, right? So this anomaly detection will look for deviations and it's going to say, hey, by the way, I've got problems, right? I still just wanted you to see that. All right, any questions about these three? Okay. Okay, so let's talk about cost optimizations and then we're just going to stop for lunch. All right, so cost optimization. So the first thing is that in that same section under the cost management filter, there's a right sizing recommendations tab, right? Now, this is going to look at your historical EC2 usage, and especially if you have long running instances, it's going to tell you whether those instances are a good fit or not, right? Now, notice I don't have any long running instances, so it's not going to make any particular recommendations. But if there are instances that are underutilized or completely idle, it's going to tell you either to downsize the instance type or to just get rid of it altogether. It's not going to do anything. It's just going to make recommendations. So just know that the right sizing recommendations is going to watch your EC2 instances, at least from the dimensions it can see, right? So if you're not sharing memory utilization or disk utilization, it won't include those as factors. Interesting. Do note that savings plans are a new way to save money in AWS against compute. What does that mean? So with reservations, you basically say Amazon years. And even if you don't actually run a T3 extra large, you are agreeing to pay for one, which of course means that you probably should run it, right? Hold on one second. I think, did you all lose me for just a second?
Yeah.
Yeah. A huge lightning strike and about, I don't know, 45-mile-an-hour wind just went on outside. So we'll see. Maybe it's a good time to take lunch. So that's different than savings plans. So reservations are basically saying I commit to pay for a year, 3 years. A savings plan is basically that you are saying, I'm going to buy a bucket of compute at a discount, meaning instead of paying $20,000, you're going to give it to me for 10, but it's going to be $20,000 worth of compute, right? So what this does is a savings plan says either it's a serverless, a container, or an EC2 instance. I want to buy $10,000, $20,000 of compute for, let's say, $15,000, right? So you can save on average about 3 cents an hour or 25% savings compared to on-demand instances. So honestly, a $20,000 buy at $15,000 is probably more realistic because that's usually savings plans offer. If you do a one, do you know have a
Hey, Michael, if you can hear me, we can't hear you at all. You're cutting out too much.
Okay. You know what? I'm a sign that we stop because I think my internet's going to be flaky until all these lightning strikes pass. So let's just go ahead and stop now. So we'll stop reservations. Well, I was like, we should stop at cost optimizations. So we'll just stop here. It's currently 11:57. Let's come back at 1:05. So take your hour minutes. I'll put up a timer, assuming it stays up, including my internet stays up. If for some reason I'm still having internet problems, I'll just roll over to the phone. Regardless, let's come back at 1:05 in about, basically an hour and 8 minutes, so 68 minutes, and I'll see you then. Okay. So, all right, everyone, we'll see you in a bit. Okay. Welcome back, everybody. Let's see here. The storms seem to have abated, so hopefully my internet connection is stable at this point. All right. So I'm going to pick up where I kind of cut off earlier around, cost optimization. This is where we left. Before I do that, does anyone have any questions at all about anything related to billing or costs that we've covered thus far? No? Okay. All right, so we already did talk about right sizing recommendations, and as far as like identifying both idle and kind of relatively underutilized instances that have low utilization. So recommendations is a section underneath if you click on the cost management, AWS cost management, you should see it on the left-hand side, along with anomaly detection. We then started to talk about how savings plans are where you can actually buy buckets of compute, right, for 1 to 3 years. Oh, is there anybody else who can't see the screen? Okay. It says I'm sharing, so I just want to make sure. Unlike reserved instances, which are like commitments to like specific like compute capacity, like a specific instance, right? Although there are convertible reservations, so don't let me throw you off. You can't actually upsize like between a family, but it's basically saying I'm going to use a particular type of virtual machine. A savings plan can only really be applied at a regional level. So whereas with reservations, you can actually buy them to commit to a particular availability zone or upsize them within an availability zone, savings plans are regional. So they differ in that you can resell your reservations. So like if you buy a 3-year reservation, you use it for 18 months and you want to sell it, you can. You cannot resell your savings plans to other customers. This is a bucket of compute that you have bought and you can't give it back, right? Savings plans are also a little different because they do not commit you to like a operating system, whereas when you buy reserved instances, you do, right? So savings plans are basically you buy a bucket of compute, and that compute, by the way, could be used by EC2, by containers, or by Lambda. So very different from reservations, which you really buy reservations for EC2, but there are other reservations for other services. But savings plans are either for SageMaker, for compute, or for EC2 specifically. Now, as I said before, reservations are specific to either family type if you use convertible, or a specific size of EC2 instance, like a T3 Nano in this case, or a small or whatever, right? So just know that under reservations, you're going to get recommendations about reservations to buy, but when you buy them, they are for a specific type of virtual machine and a specific availability zone. Compute plans are a bucket of compute for an entire region. Do note that EC2, Elasticache, Elasticsearch, Redshift, do also have RIs. CloudFront has RIs. There's a bunch. You have to look at the pricing on AWS paper, but there's a bunch of services that has reservations. So, in addition, obviously, when we're talking about cost optimizations, right, there is a cost optimizations underneath Trusted Advisor. As a reminder, you must either have a business or an enterprise support plan to get full access to Trusted Advisor. If you have a basic support plan or developer support plan, you don't get full, you get some access, but you don't get full access to Trusted Advisor. So Trusted Advisor will also send you information and say, hey, you got low utilization, you've got idle databases, right? It also will provide feedback about optimizing your account. So in addition to all those cost recommendations, the compute optimizer will also come in and say things like, and it's different from the recommender, and that basically you can just run compute optimizer. And what it will do is it'll recommend more efficient compute resources for your workloads to reduce costs. So it does use machine learning to look at historical data, like for systems that are running. And so it'll try to reduce your over provisioning challenges. So if you are over provisioned, if you're over provisioned, it'll try to get you neither under provisioned nor over provisioned. It'll try and get you into that sweet spot. By the way, it will also do EC2 instances that are part of an autoscaling group. So as you can see there, it's instances and autoscaling. The Compute Optimizer dashboard will give you very specific recommendations around, both types of groups that it'll look at. So you can actually examine the specific recommendations. Notice that the one on the right is 100% optimized. The one on the left has one over provisioned instance. This example shows an over provisioned instance. So that M5 8 extra large, they're asking you to actually convert it over to an R5 4X large. So you can see the price difference there is, like a third. So is that right? Oh no, I don't know if it's a third. Hold on. It's not a third. It's like maybe 33%, which is the same thing actually. So maybe it is a third. Not sure what I'm thinking there. So findings with autoscaling groups and EC2 instances, it's basically going to say whether the EC2 instance is under, over, or optimized. And then it'll talk about how the autoscaling groups, whether they are optimized or not optimized. So it does seemingly require an agent in order to analyze the metrics in detail. So you will have to have reporting clean metrics inside of CloudWatch for that to do this. Another thing that typically can help with costs, and you've heard me mention this around EBS and other things, is make sure you're using the latest generation of any product. So for example, if there's an Aurora, which is a RDS database type, really, has serverless, and there's version 1 and there's version 2. Version 2 is going to be faster, more scalable, and cheaper for the performance metric than version 1, right? So GP3 is faster for the per gigabyte and lower per cost than GP2. So always the latest generation. If you have an M6 versus an M5, the M6 is going to be cheaper, per CPU cycle. So as you can see here, your sustained clock speed and memory is actually higher with these instances, and the C5 is actually cheaper. And the reason that happens is that Amazon gets more and more efficient at squeezing out, power and consumption, capability, compute basically out of these systems. And so they'll make them cheaper as they get more efficient at it. So this is like great economies of scale. And notice that you're going to get a faster processor, more memory, and a better backplane at a far cheaper price than you did for previous generations. That's pretty good. So the main thing here that this module was supposed to provide to you is that how do we gain cost awareness, right? So let me ask you a few questions. If I want the most detailed billing possible, do I look at the cost and usage report? Do I look at Cost Explorer? Do I look at the bill itself, or do I look at the dashboard? Someone tell me if I want the most detailed. Good. If I want to forecast and I have historical data, which of those 4 things do I use? Do I use the dashboard, the billing detail, the Cost Explorer, or do I use the CUR, the cost and usage report? Good. If I just want to see if I have something active in a particular region, which of those 3 would probably be the easiest to use if I actually want to see if I'm using EC2 in a particular region? You actually saw me do it earlier. there's really no wrong answers for that one. You could use anything you wanted to. Even the dashboard basically would tell you what's going on, right? If I wanted to forecast the cost or estimate the cost of a project that has never been built, what would I use in order to basically estimate or forecast the cost of a project that's never been run before? Good. Or talk to your representative, like your AWS rep, right? If you have access to them. They'll usually actually run a cost calculator for you if you give them details, or they'll get on the phone with you and ask questions. Okay. Can I download a detailed spreadsheet of every single cost detail in my account? Is that true? Or like, can I do that? Is that a yes or a no? Good. All right, so some other questions. What if I wanted cost control mechanisms, right? So can I actually, first of all, get an email either on a daily or weekly or monthly basis about anything going on with my account from a cost perspective? Good. Now, what is the name of the product that I would use if I wanted to actually create segmented by service notifications to basically tell me when I was over on S3 or over on EC2, let's say at 80% versus 100%? What would be the name of that service that I would use inside the billing area? Good. Budgets. Okay. If I wanted to set up a monitor that would tell me if I was deviating from my standard spending pattern, what would I turn on? What is that called? Anomaly. That's exactly right. Good. If I wanted to save cost up to 25%, maybe more if I did a 3-year. If I wanted to save costs for being able to run either Lambda, EC2, or containers in an entire region, what kind of like billing object would I look at? Would it be, for example, would I talk to my rep? Would I do my reservation? Would I get a savings plan? So probably a savings plan if I wanted to just do it for an entire region. What if I wanted to save costs at an availability zone level and I knew my specific kind of EC2 instance that I wanted to save for? What would that be? Yeah, so that would be a reservation, or also known as a reserved instance, right? Good. By the way, with reserved instances, you can save up to 75% if memory serves correctly. Just know that with Spot, you can save up to 90% and you don't have to get into a contract. So there's varying levels of save and versus flexibility, right? So compute plans save up to 25%, a lot of flexibility. You know, RIs, you can save up to 75% with a little bit less flexibility. Spot instances, you can save up to 90%. You just have to be willing to take a hit if you get a 2-minute warning, right? So all different like methods for saving. Good. I think we just talked about optimization, so I'm not going to necessarily dive back into that. True or false? RIs, reservations, are only for EC2 instances. Is that true or false? That's right. Reservations can be obtained for other services, including Elasticache, Redshift, RDS, CloudFront, other stuff. Good. All right, so hopefully that gave you an idea of how to look at past, how to look at the present, how to look at the future, and how to optimize, like, you know, spend, and some cost control mechanisms that you can look at. Okay. With that in mind, let's talk about the next lab. Before I do that, are there any questions about any of the costing stuff? You know what? Actually, here's a good question. What did I say was one of the quickest ways to get straight into billing, no matter where you're at? So like, for example, let's say I'm on the S3 page, right? I'm on S3 and I'm like, man, I need to take a look at my billing profile. What is the quickest way to get to billing? Yeah, good. Click the name at the top, click on my billing dashboard. That is one of the quickest ways to actually get into billing. If you need to go further, like you want to actually get into cost management, just click on Cost Explorer and just click any of the links, and it will literally take you into it'll shift you from the AWS billing section. It'll actually take you into cost management. And so you'll see other options here as well. I don't know why it's actually split into two areas, the billing console versus cost management, but it is actually two different areas in the console, just to make sure I've highlighted that appropriately. Okay. Let's go back. All right, so let's talk about a lab. So this is like kind of our capstone lab. So the first thing you're going to do is you're going to create an SNS topic. Then you're going to create a CloudWatch events rule. Then it's going to be interesting. You're going to detect any drift in your stack. I didn't know you had a stack, but apparently you have a stack. I'm just kidding. There's already a stack that's been run for you, right? And so you're going to detect some drift in the stack. And then you're going to remediate the drift against the security group surrounding the web server. You're going to do this with a systems manager automation document, right? Then you're going to create a config rule around S3 bucket encryption. You're going to find some non-compliant resources. You're then going to actually use an SSM document to automatically remediate the bucket. That's it. That's what we're working on. So if we go and actually look at the details here, we open the lab up. Same thing, right? Automated notifications from systems manager. Create and subscribe to your own SNS topic, right? Create a CloudWatch events rule. Test it, obviously. You're going to look at some cloud formations, like detect a change, right? About what's going on. Perform a drift detection to find it. Then automate it, like use an automation document to fix the security group problem that you're going to find. And then you're going to set up some config rules, set up some automated remediation after you identify the non-compliant resource, and then configure that auto remediation. And that's it. There's a few challenges mixed in there, to do them. So typically we allocate an hour for this last lab. It can, go longer if necessary, but typically it's at least an hour. So go ahead and click start. There should be a number of warmed up labs already. Yeah, there's 14 at least. So good. So all for you. So let's go ahead and warm up those labs. And well, that's what we're going to be doing for the next hour, pretty much until close to 2:30, right? So go ahead and get into it, and then let me know if there's any challenges. Otherwise, I'm still here to help. And we'll do a little light review at the end, and then we'll start going through some training resources and start wrapping up the course. Okay. If there's not any questions, go for it. Okay, so in this basically the last 3 days that we've spent together, we dived into to the way Amazon wants to use services and think and approach system operations, basically, managing systems inside of AWS. So we talked about, at least conceptually, in some cases hands-on, how to install and configure AWS operating systems and compute resources, how to create automated and repeatable deployments using CloudFormation, how to use automation documents to manage and execute repeatable tasks, and then how to basically execute alarms and triggers for monitoring AWS resources. So we also talked a lot about governance and compliance, some best practices for various things, how to optimize for billing, performance, costs, scaling, and how to, some suggested troubleshooting thoughts whenever you're trying to basically troubleshoot information inside of AWS. The well-architected framework, which by the way has 5 papers, 1 for each of the pillars, is good. Understanding how AWS pricing works is probably a good paper to read. There's, probably others that are actually inside of your sheet that we shared with you about your program certification guide. Staying connected with what's new in AWS, like last week in AWS, I think is a great email that you can get that will, summarize any new announcements. Obviously, subscribing to the different AWS blogs that are relevant for what you're interested in is a huge, step in the right direction. So just know that there's tons out there. I will mention that if we go look at, did I close Firefox? That's weird. If we go out there and search for AWS white papers, there is a whole website about white papers and guides. So like if you're looking for something like the well-architected framework, assuming, oh, that's right, this is so big. Hold on, let's do this. Yeah, let's come back. Notice if you type in well-architected, you'll get like the well-architected framework, you'll get security, like performance efficiency, the excellence pillar, cost optimization, security. You'll get an overview of the well-architected framework. There's tons of stuff out there. These white papers and guides are comprehensive. So just know, like if you're looking for something special like Kubernetes, right? Amazon EKS, by the way, is the Kubernetes service. So container migration methodologies. If you're looking for migration strategies, there's things out here to look up for. Overview of Amazon Web Services is actually a pretty good one to read. A little dry, but awesome regardless. But if you need to know how to migrate databases or whatever, there's good stuff out here. This is the white papers link. Let's see. Another good thing to know is, God, what is that website? Is it training.aws? If you haven't seen, or it's aws.training, that's what it is. Yep, it's aws.training. If you're on aws.training and you click on sign in, because you want to sign in using your Amazon account. If you already have one that you use for like certifications and stuff, definitely use that one to keep it like cohesive, right? And then what can happen here is that if you search for things like, I don't know, system operations, even if you don't spell operations with the proper pluralization, you can actually find all kinds of interesting trainings and e-learnings. So for example, if you go up here and change it to digital training, this site has tons of deeper dives into specific services. So for example, if you're up here and you're like, you know what, I really need to know more about that service that Michael talked about called FSX. There it is, right? You're like, I don't really know anything about Athena. Is there anything out here? Right? Video, e-learning, right? There's tons of content out here, right? And if you look at this, obviously this one's a video. So if you launch it, by the way, it is going to ask for pop-up. So if you don't see it, just check your pop-up blocker if that's what's happening. In this particular case, Firefox should be allowing this to happen. It's obviously thinking. There we go. Way to move. So in this presentation, it would actually present everything related to the topic that I was just looking at. If it's like an e-learning, by the way, this is when you launch this course, it's not a video. Basically what it launches is this kind of very interactive kind of website that allows you to walk through videos and scenarios and drag and drop and stuff like that around the topic at hand. So like when you start the course, on the left-hand side, you'll see this little kind of like table of contents. And as you scroll through this and do the activities, it'll mark it as complete. So you can like go through and look at the customer use case. And as you scroll down, it'll actually mark it complete on the left-hand side. And usually there's a quiz at the end to kind of like challenge everything to make sure that you know, if you want credit for it, it'll show up in your transcript, right? So very, very useful site. Tons of good training here. So aws.training, great website if you want to keep that in your back pocket, if you need a deep dive into anything. They do have, by the way, things out here like complete courses like Cloud Practitioner. So you can literally notice that there's no classroom training here. This is only digital training. So literally you could take the entire Cloud Practitioner class again if you're like, man, I need to really like, dump that down. So just know there's stuff here. Now, if you're looking for classroom training, right, this is where you would actually look and find the classes. Like all of a sudden, let's say you had a huge interest in the machine learning pipeline and you wanted to know if there was a class available. You can click on the class, and then what it will do is it should take you to all the options that they have available in terms of like schedule, virtual locations. Obviously, this is all AWS proffered. You have your own internal website that will hook you into this. Obviously, I would use that, but just know if you're looking for a description on a class or you need a deeper dive on information, this is a great space for the classroom learning as well. Okay. But otherwise, I would just use this for digital training. All right, so there's that, which is, AWS.training. Certification wise, I think we covered that pretty much on the first day, but just to refresh this, once you log in, okay, hold on. Yeah, I know. Sorry, I'm messing around for some reason. I think I'm brain dead from my trip to California. When you come back here, remember, just a reminder that, the SysOps administrator exam is like level 5 compared to a level 3 and 4 exams next to it at the associate's level. So and since it is a hands-on portion, remember that you follow the quick lab stuff that we talked about. Just a reminder that this is a 65 multiple choice question exam. Some of those questions are going to be lab questions. It can be anywhere from 1, I think, up to 5. Actually, if you look at the exam guide, it will tell you. Remember that we did look at the exam guide at one point just to review everything, to make sure that we were like comfortable with the general understanding. It's SOACO2 is the name of the exam. And so just a reminder that ideally you have either 1 year of experience or a lot of time inside the console to help you manage these, to prepare for the exam itself. Remember that when you begin the exam, this is important to I know we covered this before, just want to make sure, is that you will learn about the percentage of your score that will be determined to work in the labs. Pretty much every time they convert one of your questions to a lab, you're going to be spending 20 minutes in that lab on average, right? I tend to go a little faster because if I don't know it off the bat, I'm probably not going to get it right later. But just know that's the case. Okay. Let's see. I think we covered that before, but I just want to make sure. Oh, the cost is $150. If you've already taken Cloud Practitioner, if you go actually log into your benefits, if you've taken any of the exams before, oh God, I didn't realize I had that much. Anyway, not only do you get free practice exam vouchers, but you get a bunch of like discounts on your next exams. I guess I have been using these. I have 2 accounts, so I'm just surprised there's this much in here. I actually have 2 certification accounts. You can claim your benefits, and you can get hooked in the global LinkedIn community. You get access to the store. I gotta tell you, the store is actually pretty lame. Like, I don't know. I don't even know what that store access provides. It doesn't matter. Anyway, the store has like horrible swag in it. For a company as like large and like varied as AWS, you expect they would have better swag, and they just don't have better swag. It's just not. It's not there. So just know that you can claim your benefits inside CERT metrics as well. When you go to schedule, I think we talked about this, is that when you go to schedule an exam, make sure you choose the CaO2 exam. It should be the only one left, but just in case, you should see this SOA CO2. You are going to schedule with Pearson VUE. That is going to log you into another site. Just a reminder, you're going to get a bunch of emails to test your system and to make sure your space is set up and make sure you have the right documentation. Please do not slack on that. You need to come at least 20 or 30 minutes early in order to get set up, especially if it's your first time. And you're going to want to take this in an isolated space with no disruptions and nothing on your desk. And you have to be able to see all 4 sides of your desk. So just know that you're going to have to take photos of all 4 sides and underneath your desk. So, you know, my recommendation, pull a laptop or a Chromebook or whatever you want out onto another location. Although I don't think you can use a Chromebook, but whatever. Move it out to another location, like a dining room, plug yourself in and just stay there. Tell everybody not to bother you. You don't want any disruptions. With the proctoring exam, they will acoustically fingerprint the room. If you have a little dog running around, which happened to me, I don't have a little dog, but someone brought one over. Little dogs running around, they don't like that. So just make sure that you keep your space clean and clear, okay? Reminder that since you are getting a voucher, you will put the voucher in at the very end, right at the payment page. So if you don't see it, it's at the very end. And it'll even tell you along the way, it'll say you put your payment in at the voucher at the very end. So they will try and, you know, take care of you in that way. So again, this is kind of a rehash because we have covered this before. Some people ask me, like, what's the value in certification? It's still really strong, actually. AWS certifications are still highly valued, probably even more so now because it seems to be hitting main and late adoption status, if that makes any sense. So you're just seeing it penetrate the market across the board. This, by the way, doesn't mean that Azure certifications and Google certifications aren't also like super valuable, but AWS is pretty much considered the market leader. I know, like, they catch a lot of flack, but they're rock solid. So they produce really good products, honestly, at least after the first 6 months. Ignore that course feedback. I have a link for you that I'm going to submit to you that I've been told to do in 15 minutes, right? That's going to have all your course evaluations in there. That way you can talk about how rude, crude, and socially unacceptable I was, anything that you want to like give feedback on around the labs, or anything else that you need to share just around the course in general. Hopefully we met or exceeded all of your expectations, and that you have a deeper and better understanding of all of the services related to system operations. That's it. That's it for the official content. There's really nothing else to cover. You've done all the labs, you've reviewed all the modules, you've covered all the material. At this point, you are rip roaring ready to go. And especially after our review today, this morning, we should have basically touched on all the available material. So we should be good. Does anyone have any questions about the content, any lingering questions before I switch gears into the training material to get you ready for your certification?
Quick question, Michael.
Yeah.
If we go back into the labs, is it going to be like a brand new start of that lab, or is it going to retain what we previously had done?
It will not retain what you have done. Once the timer hits 0, it deletes everything and restarts.
Okay, so it's just like you just go back through it.
You go back through it.
Okay, perfect.
Usually the lab will let you do it at least twice, sometimes 3 times. Some of the labs even went further, but just expect it after the 3rd time that it's not going to let you start the lab again, just so you know.
Okay, no, I was just checking just to review some of the things.
Oh, no. We encourage you actually to go back to the lab. So don't let me lead you down any false premise there. AWS is remarkably ambiguous about how, like, what the caps are on rerunning the labs, but it's usually 2 or 3. Rarely do people find 5 labs. It seems to be random, which I honestly don't understand. I don't want to just say it's like 3 and let's just be done with it. But regardless, you can go back in and do them all you want. You do have access to them, I believe, until November 1st. Let's see. I say that with such surety. Oh, it says December 23rd. Just so you know, it's going to be December 1st, typically. They'll usually come back in and true this up. Oh, that's weird. There's a bunch of you that are misplaced. AWS, by the way, used to not let you have access to the labs after class, but obviously since COVID, they've shifted a lot of things. So Yeah, but this will probably be December 1st by the time I come back in here. Okay. Ooh, let me just end that really quick. Give them back their environment. Okay. That's it for official content. Let's review the things that were sent to you. First of all, we have already talked about your supplemental labs and quick labs. And the only thing I would do is I would replace this with, you know, Amazon. Wow, that's just really tiny. Quicklabs.com. I would probably use amazon.quicklabs.com because it automatically scopes you into Amazon classes. If you do www, that also includes the Google classes. Here's a funny story, something you might be kind of interested in. So in 2016, I was teaching for Amazon, and Quick Labs was still the official lab provider, but they were an independent company. Google came in and bought them, even though Quick Labs did not have a single Google lab on their website at the time, not one, right? Which cracked us up because we were all AWS trainers with obviously budding Google experience back in 2016, because, Google been around for a while, but Google hasn't been really serious about the business to business cloud until recently, and so what was interesting is that they bought this company that had no Google labs, I guess because they liked the way that they did things. And so now if you go to www.quicklabs.com, just to pop into this for a second, is that you can actually see there's a bunch of Google labs here. So if we go, sign in and do our thing, no, I don't do that here. Yeah, it's here. Good. My internet is just choking out. I might have to look at this. Maybe something's eating my space. So you see Google Workspace for administrators and Flutter and all this other stuff. If you go to the catalog and you're using www, you're not actually using the amazon.quicklabs.com, you're going to see a bunch of Google labs here in addition, like Google Cloud Essentials, etc. Right? So I kind of prefer to actually do amazon.quicklabs.com because then it just scopes it out. Now, reminder that once you're here, this is the public site. This is not the private lab site. So if you want to do lab work from your class, you go to quicklabs.quicklabs. Sorry, let's start over. You go to webage.quicklabs.com. That's what you go to if you want to do the private Amazon labs. You go to webage.quicklabs.com. If you want to do the public, you go to amazon.quicklabs.com. Once you're here, again, just a reminder is that even though I have 0 credits, if you log in with your bah.com email address, if you create a user using your bah.com email address, confirm it, verify it, and log in, what will happen is that you will probably have somewhere between 100 and 1,000 credits that you can actually use for any of these labs. And again, a reminder, there are some really incredible labs out here that really will blow your mind. But if you're just getting started, just go out here and just do introduction. Right? Just do the introduction labs, and there are tons out here. Be mindful that you might not see all the labs because it does limit you to 10 per page. So you might have to expand it. You might also want to filter it against hands-on labs. But the free labs you can do without any credits, but the 1 credit and etc., you're going to need those, right? It keeps resetting it to 50. Or sorry, 10. Notice 1 credit free, 1 credit free, 1 credit free, because these are all the introduction labs. You can, by the way, scope it against tiering if you want to do like fundamental versus advanced versus expert. I got to tell you, I found that that's actually not super useful. They used to be able to make it so you could search on credit cost, which actually was an indicator of how complex the lab was. They don't do that anymore. I guess they didn't want people searching for free. But there's really cool stuff out here. Like this 8 credit lab on serverless Lambda, awesome, tons of fun. If you are on the Windows ecosystem and you want to get some time with PowerShell, great option. This, by the way, used to be a single credit lab, and they made it an 8 credit lab, which cracks me up. But there's some really great stuff. There's chatbots, there's integrations with Slack. This 10 credit lab on VPC peering and Transit Gateway, that will clear up the difference between those 2 types for you really quickly. So, take advantage of this. Oh, I haven't even seen a 15 credit lab before. Maybe they're raising prices, actually. That makes sense. It probably does cost them a lot to run this kind of stuff. Streaming dynamic content. Once again, we're running into the page limit. There's just all kinds of good stuff out here. Obviously, you want to focus on the things that you feel you're weak on, But like, for example, if you didn't really understand the difference between VPC peering and transit gateway, which, that could be my fault. I'll take responsibility for that. Or you're just a hands-on person and you just drive it in deeper. Those are the kind of labs that you want to do, right? So feel free to dive in here and just go to town. The more hands-on experience you have here, especially if you do not have production experience, please note that you want to come in here and you want to work these labs until you've got them down, right? You want to be like very comfortable with the console. And it's more important, not that you know where things are, but you know how to figure it out. If they're looking for EBS volumes, you should know that's under EC2. Most of the services are not like that, by the way. If you're looking for a database and it's a relational database, it's going to be under RDS. It's not going to be anywhere else, right? So typically, unless it's an older service, you don't have to worry about the conflation of like networking with EC2 instances, right? So just get a better idea of how to discover, and don't be afraid. Remember, they grade you on the end result for your lab portion of the SysOps exam. They do not grade you on how you got there, right? So if you got to click into 15 things in order to find it, great. But just know which 15 things you're going to click into. Don't do it randomly clicking. Obviously, if there's no VPC section, then you might end up looking under EC2 for that. But, obviously there is a VPC section because we all saw it, okay? So just be mindful of all that stuff. Come in here, practice. Now, the other thing that other than getting these supplemental labs, make sure that this little guide that we sent you that has these links in here, some of these links, by the way, are going to take you straight to Tutorials Dojo. Awesome. Because guess what? We want you to use Tutorials Dojo. We certainly want you to use the SysOps exam. Let me sign in first, right? And this could be incredibly spectacular, right? I got to tell you, if there was anything that you did other than just getting in here and kicking on the console with Quick Labs, getting in here and actually doing this SysOps test is going to be absolutely essential. Doing the practice exam, at least 2 of the exams, is going to be super key to make sure that you are finding any gaps, clearing out any knowledge. Wow, almost pulled my USB port out. So could not emphasize this enough, but this little sheet right here includes all the white papers, some of the digital trainings, other stuff. Do you actually need to read all this in order to pass the exam? You probably need to skim it, right? Do you need to memorize it? Absolutely not, right? But at least high level broad strokes, you probably want to digest this, to a certain degree. But if all you're really willing to do is actually just do the practice labs and quick labs and then do the practice exams, that will get you close enough. It would probably be ideal, though, that you actually just at least skim some of this material. Not necessarily the labs, but at least the white papers. There's some multi-lab workshops here on systems manager and observability. Those could be super useful. But again, if you're already familiar with X-ray, then don't do a lab on X-ray. If you already know the well-architected framework, then skip the white paper, right? If you don't, just know that is not only going to build your confidence for passing the exam, it's going to give you more mental models and more information for when you have to deal with AWS. So just know where it says ILT, you can just skip that. That's just an instructor-led, interaction. Don't worry about that. And they might offer you a post-certification class. We'll just see what. It's like an hour meeting with me, and basically we go through and talk about stuff. I don't think that's on the books yet. If it is, Greg will let me know. But for the time being, if you see ILT, just skip that. You've already done that, right? And I think that's it. As far as this sheet is pretty simple. It's got a web page, a white paper, digital training, a couple of videos, and then a bunch of workshops and labs. That's it. Okay. Last little piece. I'm going to send you a couple of URLs that are going to drive information around system operations deeper, even beyond these. They are a little bit over and above Quick Labs. They do require a personal AWS account. One of them you've seen already, and that is ec2spotworkshops.com, right? You've already seen this. So this is one of the ones that I was talking about, and you wouldn't run everything here. You would just maybe run the ones relevant for auto scaling or different licensing types. But unless you're super interested in SageMaker and the other services that we did not talk about, I probably would skip the rest of this and just focus on the ones that are relevant. The other thing to look at is the well-architected framework. That there's a well-architected labs workshop. This one we talked about a little bit. This one, again, you probably stick at the 100 level for, but if you're like, I'm really weak, Michael, on cost optimization, you might come out here and actually run one of these 100 level labs, right? Again, your discretion. I probably wouldn't do the 200 level labs unless you've decided all of a sudden that you're going to take the DevOps engineering exam, but you're training for the SysOps associates exam. So just stick with the 100 level labs. Don't go above and beyond. You don't need that, right? Let's see. Other things to note is that there is a transit gateway workshop. It's called AWS networking, and there are pieces in here for private link VPC peering. This is a great one, right? So you can do this as well. Remember that there's also one on Quick Lab, so you might not need this unless you just want to go that extra mile. Just know that if you go to aws.workshops, is that right? Where are you? Workshops.aws. Wow, I must be dyslexic, but with whole words because I keep getting that backwards. Just know that workshops.aws will also get you hooked in with a bunch of workshops. It will require your own free account. But if you're looking for something like, Michael, I really need to know more about containers, right? Well, there you go. There's some containers. By the way, you could also just click on containers up here, right? Which would also kind of like, hey, here's the CI/CD ECS workshop. Here's, ECS demo go and stuff like that. Okay. This is probably a portal to way more information than you actually need. So again, a reminder, do the workshops that are relevant for your exam. And then later on, you can come out here and have a free for all and play for everything else, right? So if you ever need more workshops, I probably have like 100 workshops that I can give you that are even above and beyond what these guys are offering right here. But mainly just focus on the ones that help you pass the exam. Otherwise, it's too much information, right? So my general recommendation, follow this white paper, do some quick labs, maybe revisit some of the labs we did in class, and then study the practice exam. These blocks, by the way, are meant to be done about in 5 hours a week. So like this little blue block, this green block, this blue block, these are all meant to be done within 5-hour chunks about once a week. So this will basically, since you've just taken the class, this will allow you to basically complete this in a week. You complete this in a week. You complete this in a week and complete this in a week. Notice that's only 3 hours actually, but it will require 3 to 5 hours a week of about 6 weeks worth of investment to really get you ready for the exam. You could do it sooner by putting in more time. Just a word of caution, try to do a little bit every day instead of saving it for a massive investment, say on a Saturday. I know you're working, I'm working too. I totally get it. I actually have to study for the DevOps engineering exam, which I have to recertify in, and the machine learning exam while working. I totally get it, right? And just know that when I get done with those periods, I'm like, whoo, that's so good. But it is 8 weeks of my life of an extra 5 hours a week. So, but it's worth it. So just know that you want to do a little bit every day over a massive investment over like the weekend or whatever. Okay. Good. All right. So it's 3 p.m. So I'm going to grab the link for the evaluation. But does anyone have any questions about the training material that I'm going to resend all of this to you through email? Any questions about any of that training material? Any questions at all about certification? How to approach this? Any of that? Okay. All right. Well, let me go ahead and post this out for you. Let's see. Where is the evaluation link? I just lost it. Here it is. Okay, cool. All right. So I'm going to paste this in the chat. Do me a favor and go ahead and take 15 minutes to fill this out. Once you are done, and you can take a 15-minute break if you want. At 15 after, you're going to come back and we're going to run through some exam questions. I'm going to check in at 4 o'clock. I can kind of sense that people are slowing down. But know that after you finish this evaluation, that's really the official close of everything in class. So I'm going to continue recording just to record the practice exams. But otherwise, if you need to go or leave, oh, yeah, the link would help, wouldn't it? Yeah, thanks for that. magical telepathic evaluations. So all we're going to do from this point forward is just run through practice exams. I'm going to check in around 4 o'clock just to make sure everyone's not completely done. And then if we want to keep going, we'll keep going till 5. So take a 15-minute break otherwise, but if you can, fill out the evaluations and we'll resume here in a bit. Okay. I will be back in 13 minutes. Does anyone need any extra time? No? Okay. All right. So I thought I would start us off a little different than we've started before when we looked at this, in that I thought we would take a look actually at the sample labs first. Thought maybe you might be more interested in that than even the trivia, because I think the trivia you can do on your own. I mean, and you can do the sample labs on your own as well, right? But I thought maybe we might talk about the breakdown here instead, right? Okay, so underneath, actually, when you get the actual practice exams, there's actually a section for the example lab scenarios. For example, creating an alarm metric filter, right? Using an alarm using a metric filter. So let's take a look at this, for example. Okay, so here's the lab exercise. You got 20 minutes as a learning objective, right? We're going to focus on basically all things CloudWatch plus SNS, but specifically CloudWatch metrics, CloudWatch alarms, and CloudWatch logs, right? So in this scenario, we're gonna have to create a CloudWatch alarm that publishes a message to an SNS topic when triggered. The alarm state is based on a custom metric filter generated from a CloudWatch log group. You also need to test the metric filter if it correctly filters the logs based on the criteria, right, mentioned in the instructions. Okay. So the first is that you want to create an SNS topic and name it TD instance alarms, right? Then you're going to create an email subscription to the topic using this particular email address. Create a log group and name it TD instance logs and configure the log groups to retain logs for 1 year. Create a metrics filter, right? Using the TD instance logs log group and name it TD instance metric, right? Create a filter pattern that monitors all of the 500 level errors and name it this filter. And then use these log events to test the pattern that you created. Create an alarm using the custom metric filter you just created. And then configure the alarm to evaluate every minute and set the total threshold to greater than 5, and then set the alarm threshold to 3 units. Then publish a message to the TD instance alarms topic when the alarm state is triggered, set the alarm name, and you can stop at this point and try the lab exercise by yourself. Else you can proceed through the walkthrough they've created to guide you to perform the lab exercise. So this is where having your own personal account makes a lot of sense, but also like doing it with the lab guide may also make sense. For example, if we go back, I guess I logged myself out. Hold on 1 second. Well, that's right, I closed it earlier. That would be a problem. All right, so I'm logged back in. So what you do is you go into SNS, right? And then you create your own topic. Now you got to remember, by the way, everything you create. So got to make sure that you're paying attention. So let's say I create a topic. In this particular case, this is an SNS topic, right? They didn't really specify anything about like, oh, that's interesting, FIFO versus standard. Huh. In this case, it's TDD instance alarms. So you could basically, you could just do standard for this if you wanted to. We're going to call it this. Display name could be the same if we want to. Notice it didn't ask for anything else. You could just create the topic, right? And then what you'd have to do is you have to create a subscription. Now, in this particular case, the subscription is going to be email. We don't have to change anything else. And the endpoint is this lab piece that's here, right? As far as TD labs. So then you would come back over here, paste in TD labs. Did it say anything about a filter policy? No. So no filter policy. By the way, filter policies allow you to redirect it. In other words, you could send multiple messages across an SNS topic, but the subscription could only be filtered to receive a message if it says, you know, targeted group equals production or targeted group equals dev. In other words, the subscriber actually controls what messages they receive by filtering them out as they're published to the topic. So it's actually pretty cool. So then we create the subscription. Is that not, oh, sorry. Wow, that's some bad parameterization, Amazon. Do better than that. All right, so now I have a subscription, right? There's the email endpoint. Obviously, they send an email out to pending confirmation. Now, I could also stuck my own email address in there, so that's big of a deal. But I was just following the instructions literally. And then we got to go create a log group. So someone help me out. Where would we go to create a log group? CloudWatch, right? All right, so go to CloudWatch, right? I'm assuming since it's a log group, it's going to be under logs, right? So here's a log group. And so I can create a new log group. In this particular piece, I can actually just create a log group called TD instance logs. I think the retention setting was set for 1 year, right? So I'm going to set it for 1 year, 12 months. Everything else is optional. So there's my log group. And then I'm going to create a metric filter, right? Using the TD instance logs. Hold on 1 second. And then name it basically using the TD instance logs groups and name it TD instance and a search for 500 errors. Now, let's say I'm sitting here and I'm going, oh, do I know exactly how to create a metric group? Now I just walked through everything else, right? I know how to create the email subscription topic. If you're like, all of a sudden, like you're like, I don't remember exactly where to go. You could literally just scroll down and just change it, right? To whatever it is, right? So create a filter pattern. So in this step, you would link to CloudWatch, then obviously you click on log groups, select the name of the log group, and then select actions and create a metric filter. So click this, then click on actions, create a metric filter. So you see now how they're kind of like, hey, this is what we're looking for. And then in this particular case, it literally just walks you through everything you do, right? So on the create metric filter page, to find the filter pattern, we need to understand the anatomy of a log event, So suppose you have a stream that looks like this, you should be able to filter events that contain by creating a filter pattern like this. So they do expect you to be able to create your own filter pattern, right? So you have a search condition that basically looks for a 5-star on the status code. So in this case, right? And then you can basically use this as your test pattern. So you can basically pop this in. And here are the results, right? So all of your 500s show up, but not your 200s. So then you know that's going to work. So you define the pattern, you've tested the filter to see if it's working, right? Copy those events in. You should be able to see full results, which we did. Assign next, and then you create the filter name, which in this case is the well, hold on, just make sure. Where's the filter name? There it is. Oh, not that. Let's go back up here. Because what they were asking for was this particular name. So I would assume, by the way, that if you get the names wrong, you're going to fail because they basically want you to follow it exactly. So in this case, it was, that's an alarm. What I'm looking for is this actually, is this filter. Doesn't really say anything about any other kind of like pieces as far as namespaces or whatnot. These are all look like they're optional. Oh, the metric name must identify this metric. Huh. Metric details. Okay, let's see what else it says here. Just following along. Just want to make sure I get the names right. It doesn't give clear instructions. So filter patterns working, 4 results, assign the metric. Oh, I see. They just put test metrics in there. A metric name was exactly the same. Okay, cool. Okay, metric value of 1. the value published to the metric name when a filter pattern match occurs. That was 1. Good. Okay. Default value, let's see, would be 0. That's optional. No unit definition. Hit next and create metric filter. Good. Okay. Now I ran through that pretty fast. Obviously, you know, you're going to want to understand exactly how to do this, but these are the great scenarios that allow you to kind of understand how this kind of like functions. And let's create the metric filter. Perfect. All right. Now we have to create an alarm using that custom filter that we just created, right? So we're going to go to the metric filter sections of the TD instance log group. There's no need actually to go to the alarms page. You could though, right? So go to the TD instance log group and select the metric filter section, right? So here are our TD instance logs, here's filters. Select the metrics filter you just created and then choose create alarm. All right, so check it here, create alarm. Now that literally cut us over to CloudWatch alarms, by the way, just so we're aware. And then let's see, according to the instructions, we want to set up basically a metric name for the alarm, call it sum, right? Or sum. Statistic is going to be sum, period is going to be 5 minutes. So let me change that to 1 minute here. Configure the alarm to evaluate every minute and set the total metric threshold to greater than 5, and then set the alarm threshold to 3. All right, so we already set the statistics to sum. That's all done. Set the conditions greater to 5. Okay, so that's actually down below. So greater than 5 as the threshold. The instruction states that set the alarm threshold to 3 units means you need to find the number of data points that must be breached that causes the alarm to go into an alarm state. So since it's 3 units, that means both the evaluation period and the data points to alarm should be set to 3. So if we look under additional configuration, you basically just set this to 3 out of 3. Doesn't say anything about changing the treat data as missing, but that's what, you know, that's what's recommended is basically 3 out of 3. So data points 3 out of the 3 like consecutive alarms need to alarm in order for it to trigger the alarm. It's not 2 out of 3. It's not 1 out of 3. It's 3 out of 3. And then you hit next, and then you're done. Now, in configuring actions, right, we want to do a notification. So we're going to do an alarm, and we're going to select an existing SNS topic in this particular case. Now, all you need to do in order to get this to function is just click on this, and this should show the TD instance alarms has a subscription possibility. It'll even show the email endpoints that are available, right? So notice here they did td-labs@gmail.com. Obviously, I could add my own subscription, my own name to that. And then set the alarm name to TD instance-alarm. There we go. No descriptions needed. Click next. We're good. Then they'll say, hey, do you want to preview and create? Yeah, I know. So that was the whole thing right there. That was the whole scenario just running from beginning to end. Let's verify that just by looking at the instruction set one more time, right? So the first thing we did, we created an SNS topic. That's done. Create an email subscription using that particular email address. That's done. We could change it to verify. Create a log group, right? Then create a metrics filter using that pattern, which is what we did. And here was the data that we were using as our test filter data. Then create an alarm using the custom metric filter that we just created. Configure it to be a threshold greater than 5, but 3 out of 3 sets an alarm. And then publish a message to the topic when the alarm state is triggered. Set the alarm name to TD instance 5 alarm, right? So it looks like we matched all the criteria, right? So this kind of thing got us like super like familiar with the console and how to like run these particular pieces. Obviously, there's a little bit of a warning here because I've got some pending subscriptions, right? Let's go out here though. Let's go back to SNS. Anyway, doesn't matter. In the lab environment, what would happen is that they would then check to make sure that you had all of the objects that they expected you to create with the exact configuration that is needed. All of the other configurations, they wouldn't necessarily check. They would just verify that you had an SNS topic with the proper name, that, you know, had the threshold set correctly, and that everything object was, you know, set in relationship to everybody else, right? So that's a lab scenario. So you can come in here and run through the lab scenarios anytime that you're ready to, but I would highly recommend that you actually run through all of these sample exam lab scenarios. John pulls these either from the practice exams that the Amazon publishes, which are honestly not that great. Excuse me. Sorry about that. So I'd highly recommend that you actually run through all of these when possible. Any questions about this, its applicability, using this as an exam scenario? Between this and Quick Labs, you should have a bunch of scenarios covered. Okay. Let's do a run through for maybe the next 30 minutes, and I'll just check in and see where everybody's at.
Quick question, are any of the labs not supported with a free tier AWS account?
Any of these lab scenarios?
Yeah, any like the tutorials, dojo, or any of the ones that you've kind of mentioned on the different sites?
I would not assume that any of them are free tier, but the only thing I can tell
Okay.
you is that they cost less than $1 to run.
No, that's fine.
Right? Yeah.
Okay.
Yeah.
I
Adam,
just didn't
so
know.
we don't give you any labs that are instantly going to put you at like a $5 or $10 deficit, right?
No, that's fine. I was just checking on what we need to do as far as, like I said, getting signed up.
No, it's a fair question, because if you do these labs halfway through and then leave the resources up, you could end up spending more than $1, right? So, it's a fair question. This is something that has been going around a lot. It's been high profile with AWS recently, as they don't give you a way to play with the services that couldn't potentially cost you a lot of money if you abandon a lab and come back 5 days later, right? So that's the only catch, is that anything that we have asked you to do with your personal AWS account, just make sure that you don't stop in the middle. Start the lab, finish the lab. At the end of at every single lab that we have suggested thus far, there is a cleanup section. This is the only one where he doesn't have a cleanup section. But quite frankly, creating alarm in this topic is going to cost me like pennies on the dollar. So, but everything else, like Quick Labs cleans itself up since it does it in its own account. But all of the well-architected labs and all of the partner workshops, you do actually do that in your own personal AWS account. So, but every one of those, every single one I've seen at the very end has a cleanup section. And so it literally walks you through all the scripts to clean it up. So this is for everybody. Just make sure that you don't stop in the middle of the lab, walk away for, 5 days and then come back. You will incur costs. Again, that you might spend $5, but still it's like, I always joke with people. I was like, we love the surprises that we want. They're not surprises when we don't want them. They're called problems. So in this particular case, just make sure you do the cleanup section.
Yeah, I appreciate that. I was talking more from the cleanup. So thanks for explaining that second part of that as well.
Yeah. It reminded me to come in and clean my own stuff up, actually. Yeah. Having log groups doesn't cost anything, and SNS doesn't really cost anything either, but just to be cautious. This is how you end up with lingering stuff. Okay. All right, so any other questions? Actually, let's go. This time, let's do some section-based ones instead of review mode. So we'll do a few out of each section just to get a feel for it, okay? So let's start with monitoring and logging first. Oh, John, we're gonna have to talk about your website. Okay, so I'm not going to do any analysis unless I see something really distinctive. Otherwise, I'm going to let you all answer. Okay. So social media companies has hired a SysOp administrator to ensure all of their CloudFormation stacks have the latest Windows AMI. The solution should have minimal management overhead because they need to update their Windows AMI again and again. They just want to stay with the latest Windows AMI. What's the most suitable option? Now, we've seen this question before, so hopefully this is an easy slide into doing exam questions. Is it 1, 2, 3, or 4? I see 2 votes for 3. Looking good? All right, let's check it. Pretty sure that's the answer. Okay. And that was part of the public parameters that we covered when we were looking at parameterization inside of CloudFormation, that you could actually refer to these public AWS parameters about latest AMIs and stuff like that. Okay, next one. We're managing a web application hosted on an EC2 instance. The security groups and network ACLs are configured to allow both 80 and 443 traffic in your instance. A manager has received a report that a customer cannot access the application. The administrator is instructed to investigate if the traffic is reaching the instance. What is the best approach to satisfy this requirement if we actually want to see the traffic hitting the instance? All right, so one person has posted privately to me about flow logs. Another person posted flow logs. Sybil, you posted CloudTrail logs. Okay, good. Now, another said CloudTrail logs. So thus far, I have three votes actually for, no, I have 3 votes for CloudTrail and 2 votes for VPC flow logs. So I'm going to choose CloudTrail because that's what the majority has chosen. And so it's actually flow logs. So just remember that CloudTrail is only for API calls, right? API calls that are actually hitting the AWS API. Network traffic hitting a web server, well, that's a whole different type of data, right? That's about network traffic coming in. The only thing that would give you information about network traffic flowing in is the VPC flow logs. Now, if there was a load balancer in process, you could actually grab the load balancer access logs as well. That would be very useful in troubleshooting. But notice that no load balancer was listed here, right? So it's not stated in the scenario, and access logging is disabled by default, so you would have to enable it, right? CloudTrail is primarily used for API logging. It can't capture network traffic. But VPC flow logs, that's exactly what it does, is it shows you networking traffic. CloudWatch logs wouldn't work because CloudWatch logs are about metrics about services and systems, not what the actual services and systems are actually doing, right? And again, it depends on the service, but that's generally true. Okay. All right, so we've got a financial tech startup that's running a cryptocurrency exchange platform hosted in several EC2 instances, and they're behind a load balancer, an ALB to be specific. The stack is deployed using CloudFormation, and each EC2 instance has a running SSM agent. There was recently an incident in which the platform was down for a few hours because the instances have reached the maximum disk space allocated. What should the sysops administrator do to prevent this issue from happening again? One, two, three, or 4. Okay, so let me throw some analysis out there and let's see. So first of all, it says that each EC2 instance has an already existing systems manager agent. So, but does that mean that you still need the CloudWatch agent as well? That's a good question, right? Can you collect metrics from the SSM agent, or does it require the CloudWatch agent and the SSM agent to collect metrics? That's an important distinction, right? So 1 looks like a pretty solid answer, actually, because if you do, you might need the CloudWatch agent distinct from the SSM agent. They probably serve different purposes, right? So let's stick with that for a second. Using drift detection on the CloudFormation to detect blah, blah, blah. No, that can't possibly be it. First of all, CloudFormation wouldn't detect a change in disk space, so that doesn't make any sense. Number 3, enabling detailed monitoring CloudWatch to track the disk space metrics of all EC2 instances. Well, okay. Remember that disk space is a function of having something inside the operating system, like an agent, right? Enabling detailed monitoring, all that does is change it from 5-minute intervals to 1-minute intervals. So that wouldn't necessarily give you information about the disk space. And then integrating AWS health events with CloudWatch events to collect disk space utilization. Again, we're still having an issue is that even though SSM agent is on there, you need a CloudWatch agent in order to gather all the information. So let's see if one is the right answer, because quite frankly, it looks like the right answer, right? You put a CloudWatch agent on there, you collect disk metrics, and then you set up an alarm to key off of them, right? So that's a distinction. Some people mistakenly assume that because you have SSM on there, you're able to get metrics. But each of the agents actually do different functions. Like you still need code deploy on there to deploy code in addition to CloudWatch, in addition to SSM, right? So one is the right answer because drift detection and CloudFormation isn't going to help. Detailed monitoring isn't going to change anything. And health events and CloudWatch is not going to allow you to see disk utilization. Remember, that's the one thing that requires you to have an agent inside the operating system. So that's why one is the right answer. Okay. Next, we'll do this last one, and then we're going to switch over to a different section. So a digital advertising company is hosting an HRIS application, a HRIS application on EC2 instances. The application should be accessed internally by employees. So the administrator set up site-to-site VPN between AWS and the on-premise network. The administrator needs to have a monitoring mechanism that detects any activity that exposes the application externally and restricts the action right away, right? So which steps should the administrator perform to achieve the requirement in the most operationally efficient manner, right? So we need a mechanism that restricts access the minute something's exposed, right? Oh, good. And they're throwing some monkey wrenches in here as well. Okay, seeing some guesses. All right. So I saw a couple people put 3, so I'm going to do that. Let's see if 3 is the right one. Yeah. So why? So first of all, it says that it wants you to stop the association. So like, I'm sorry, stop the exposure. So what's interesting is that if we look at number 1, the Lambda function that removes inbound rules on security groups associated with the Elastic Network Interface, enable VPC flow logs to send Amazon CloudWatch logs, create an alarm that matches I don't know that it needs to be that complicated, right? That's not the most operationally efficient approach, is to look at the VPC flow logs. If the security group is opened up to the world to a non-corporate range, then just shift it back, right? Now, EventBridge targets the AWS system automation document to monitor public IP addresses continuously. Once a public IP is found, initiate a new systems manager document to terminate the instances. 1, we probably wouldn't track it by public IP address. 2, we certainly wouldn't terminate the instances because then that would take the application down, right? We're not going to do that. So that makes 2 invalid. But then we got 3 or 4, which are basically the same thing. You're using an AWS config rule. 1 is managed, 1 is custom. But the 4th one is actually deassociating public IP addresses from the EC2 instances. Now, again, just because it has a public IP address doesn't mean that anybody can get to it. The firewall is still in place. And so I don't know that you want to strip off public IP addresses because that will also give them a static IP address. So there might be a reason for why that's happening. The most operationally efficient way to do it is just to stay focused on the security groups because that's the thing that's changed. Someone opened up a security group, just put the security group back, right? So here we're going to create a custom AWS config rule that continuously evaluates whether a security group allows inbound requests that are outside of the corporate range. If they do, we're going to apply a document and we're going to remove the non-corporate range from the security group. Just that simple. You do require a custom rule for this. It cannot be a managed rule. So that's why 3 is the right answer. Good. All right, we're going to pivot over to reliability and business continuity. I think it's the other thing. I can't remember. Yeah. Okay. All right, so we got a technology consulting company that launched an RDS MySQL instance. It's going to host a heavily used relational database. Manual snapshots of the database are done on a schedule when the company conducts its disaster recovery activities, right? To meet the strict compliance requirements, the SysOps admin needs to ensure that there are no outages when a snapshot is being created for the database. So how do you do that, right? How to ensure that there are no outages when a snapshot is being created of a database. I love their use of the word. What's the best way? Okay, so I see a couple of 4s here. I actually think taking a read replica is pretty valid, right? I think that's like a great option. But interestingly enough, if you actually like use a multi-AZ deployment configuration, what's going to happen is that it's actually going to take backups from the second box, the passive box, not the active box. So with literally a checkbox, you literally can just instantly set up a second instance. It's going to be of the same size. It requires almost no management overhead because once it's set up, it doesn't really interfere with what's going on with the primary. And then that's it. So in terms of like best way, I think a read replica is totally valid because what if you don't need active passive failover, right? But you know, it is actually recommended best practice that you run all EC2 type instances in 2 availability zones. And that is the operational, like most operationally efficient way to do it. A read replica does require more configuration and setup than using multi-AZ. So let's see what John says about why that's the right answer. Although this can help IO suspension. Oh, that's right. This is asynchronous reads and writes. So you're right. A read replica could be out of sync. That's the other thing I didn't think about is that because of read lag, you could actually have a read replica out of sync because of it's an asynchronous replication. With multi-AZ, the second box is in 2-phase commit lockstep with the first box. So there's no way you're going to be missing any backups on that. And the load's going to be less because the only thing the second box is doing in a multi-AZ setup is all it's doing is replication. So it's not taking production traffic. So it's got plenty of capacity to actually receive the backup. Okay, I can see that. Good. Okay, here we go. A SysOps admin needs to set the architecture of a web application in AWS. It should be deployed in an auto-scaling group of EC2 instances with an ELB in front of it to distribute traffic. The administrator was also instructed to route certain requests to specific target groups of EC2 instances based on URL paths. The EC2 instances should be able to withstand CPU bursts for long periods of time. Which of the following options should the administrator do to ensure the application will be deployed in AWS in a cost-effective manner? So we have 2 questions. 1, what do we need to do for the load balancer? And 2, what do we need to do for the EC2 instances? So we have to make 2 choices here. First of all, let's do the load balancer one. Is it 2 or 3? And if it's, you know, if it's one or the other, why? Why is this application load balancer the answer? What did they say up there that makes it? Yeah. URL paths, right? That's totally it. Okay. Now they have to be able to withstand CPU bursting for long periods of times. Yeah, Isaac, I'm thinking about like you. Like I first, I will tell you, I don't remember if T2 Unlimited is actually a thing. I think you can click it. I think there's like costs for it, but I don't think I know that I've ever deployed one. So I'm going to assume this could be it. The problem with just a straight up T2 is that it's going to have limited capability to withstand CPU bursting. So I know it's not enhanced networking, right? And we've already taken network load balancer off the table. So I'm pretty sure that this is going to be the answer, right? So T2 Unlimited. So let's look at this for a second. Well, it doesn't explain T2 or T3 Unlimited, but I do know that that's a mode where basically their CPU burst, you pay a little bit more, but there's no CPU burst credits. The thing just bursts as needed. So this is an interesting statement. Deploy a burstable general purpose type that are cost effective. So although it is cost effective, it cannot sustain a high CPU performance. You should have used T2 Unlimited instead. Okay, makes sense. Okay. An organization hosts its OS database and applications on an Amazon EC2 instance backed by multiple EBS volumes. The sysops admin plans to automate the process of taking AMIs, but when performing the backups, he has to ensure the integrity of created images. So automatically, when someone brings up anything about the integrity of the created images in relation to creating AMIs, what do you know about the machine that's being imaged? What do you know you have to do in order to make sure there's consistency? We went through this before, so hopefully people remember. You got to reboot, right? There's no way around it. You got to freeze the file system somehow. So I think we looked at this one before, actually. Yeah, so which one do we think it is? I think we know that backup's off the table. So really the question is it 1 or 2? Right? It's probably 2 because 2 has a reboot parameter. This is not used for creating images, right? But this is, right? So let's check it out. What does it say? It is 2, right? Because of the reboot parameter, right? These two basically said the same thing, but either with no reboot or reboot. That was it. So we now know if someone brings up in the question and they're making images, we need to make sure the file system's integral, then that's going to be what we say. Okay, good. All right, we'll do one more and then we'll switch gears. Companies hosting a multi-tiered web application that consists of an e-commerce module as well as blogging site that fetches data from a database. Some articles, which are static web pages, have lots of page hits, sometimes cause the application to page slowly. Static web pages, interesting. Which of the following can be used to alleviate the issue of slow loading times when many users are visiting the applications for these pages in the most cost-effective way? So this is a key use case for one of the services inside of AWS that you hear about all the time. It's one of the things that it is primarily used for, is this use case. So which of these services that are listed in the answer are going to be primarily used to host static assets, off of a web server? Now, notice I said static assets off of a web server, not static assets off of a database. Right? If it's a different answer, because they're trying to fool you here, is that if it's off of a database, there's a different service for that. If it's off of a web server, there's another service. There's actually 2 services, but there's another service for that. So in this particular case, I see a bunch of 1s for Elasticache, but the problem with is that Elasticache is not used for that purpose. Elasticache is used for caching databases, right? So S3 is actually the right answer for offloading static web assets. That's exactly what S3 is. One of the primary use cases S3 was designed for. So notice it says here, Elastic Cache is for content fetched from a database. Read replicas are for offloading workloads in relational databases. And DNS doesn't even make any sense. So we're just going to ignore that altogether, right? But this particular use case is exactly what S3 is used for. So if you see someone in the question say static web assets, you're either looking at an S3 or S3 and CloudFront. The minute you hear static web assets, that's what they're going to say. If they say database caching, then you're going to instantly think Elastic Cache, but you're not going to think S3, right? Elastic Cache is going to be your friend in that use case. Okay. Let's switch to deployments and provisioning. So we're going to switch. We're going to do 4 questions from each. Now I just want to check in. It's 3:55. My intention is to do 4 questions from each, but if anyone needs to drop or go, that's fine. You know, we're probably going to take another 20, maybe 30 minutes to finish the remaining 4 questions in each section. And then I'll check in again. If anyone is absolutely done, brain dead, and you need to drop, just know that certainly I will not hold it against you if you want to. Otherwise, I'm just going to do 4 more questions from each of the sections, and then we'll probably call that a day, unless you, and I'll check in and see where everybody's at, and we'll keep going. Okay. Okay. We've got a large IT consulting firm that is using Puppet Enterprise for their infrastructure and application management on their on-premise data center. The firm has recently adopted a hybrid cloud architecture, and they require some of their applications to migrate to AWS. Which of the following would be the most suitable and manageable service to use for this scenario if they are indeed using Puppet? There's only one answer. The minute you see Chef or Puppet come in as a service you want to mimic inside of AWS, there's only one service that can do that. Don't get me wrong, you can run it in EC2, but I'm talking about a managed service. So if you want to like run Puppet and Chef inside of AWS, there's only one answer. And by the way, I see a number of people voted for 3, which is Beanstalk. Beanstalk is a wizard for EC2. So OpsWorks literally can run Puppet manifests or Chef recipes or cookbooks, whatever. So OpsWorks is actually the answer if you want to run Puppet or Chef in AWS using a managed service. It's the perfect service for this. All right. Let's go to the next one. A trade finance application is using Lambda API Gateway and the RDS Aurora database to process financial transactions, such as letters of credit, factoring, and accruals. A new version of their application is ready to be pushed to production using Code Deploy as the deployment service. Hold on just one second. My son is calling. I just want to make sure he's okay. Okay. Sorry, he's fine. All right, so here we are, new version of the application is ready to be pushed to production, and you're using Code Deploy, which by the way, requires an agent. So you have to specify a percentage of traffic to shift to your updated Lambda function version before totally shifting the remaining traffic. So like you want to put a percentage in there and kind of test it first. So you can do post verification tests. In which of these is the most suitable configuration type that you could use? If you just want to test the waters, right? You don't want to necessarily go all in, right? But you want to shift a little bit of traffic to your new version, run some tests, and then go all in once it passes. What is that? Oh, I'm seeing some good answers here. Okay, so 1, blue-green deployment would be one option. Now, first of all, can we say that all at once just sounds risky, so we know that's not on the table? All at once doesn't make any sense, right? We're like, we're not doing all at once, right? Now, blue-green deployment, that's A/B testing, right? That could make sense. But I do want to mention that A/B testing is all over to another version, and then you cut back. So that might not be the right version for us to do. Linear basically says, I want to do 10% for 5 minutes, then another 10% for 5 minutes. And I just want to keep doing that every 5 minutes until I've rolled everything over. Canary is the one, it's an old reference to like canaries in the coal mine, which is a horrible practice. But like we would bring birds down into coal mines with us. And since they have more sensitive lungs, they would get sick before we do, right? So, right? And so a canary deployment is where you just stick your toe in the water. You put 5% of traffic, 95% the old version, and you just test that traffic, right? So in this particular case, it is actually canary, right? So, and think of canary as just either a modified linear or a modified blue-green deployment. It's A/B testing, but it's like tiny b versus big A, meaning traffic is still split between the two environments, which is not what you typically do in blue-green. Blue-green typically is you roll everything over and you roll it back if something fails, right? So you do need to know those traffic types. So this is a great question to have because you now know that linear is a percentage over time, the time interval. Canary is a little bit with a lot being left over in the original version. Blue-green is a complete cutover from one version to the next. Okay. Okay. Question number 3. SysOps admin needs to install and configure software applications to an EC2 instance that's going to be deployed using CloudFormation. So this is good to know. The admin has to ensure that the applications are properly running before the stack creation proceeds. Which of the options can satisfy this? What can satisfy that requirement? What can we use when we need to actually make sure that in another system, it's actually ready to go and it sends something back to CloudFormation to let it know that it's ready? What do we use for that, right? Isaac. I was thinking the same thing, actually. I was like, well, it's going to be 2, 3, or 4. So, right? Is it an update policy to the instance? Is it a creation policy, or is it an update replace policy, right? So 3 is probably the most common vote here, right? And, good choice, because here you are still using CFN signal. So CFN signal, once the operating system is right, it's just going to send a signal back to CloudFormation and say, hey, we're good, right? The application is up and running. We're ready to go. But it's the creation policy attribute that, that's added to the instance definition that sends that success signal, okay? Yeah, so just remember, CFN init is definitely not it, right? It's CFN signal, right? This one's incorrect because this attribute is usually used for updating resources and rolling, for stack operation updates. This is used to retain, or in some cases, back up a resource if it is replaced, right? So you basically like back it up before you actually replace it. Okay, that was question 3. So we're going to do one more in this section. Okay. So a data analytics firm has opened a new service center in Africa, and they want to be operational in a few days. The new service center decided to contact company headquarters to request a list of resources used in other service centers. You have prioritized creating a CloudFormation template that includes these initial resources that are crucial for operations, and you tell them that the remaining templates of less important things will follow. So what do you think will be the most important things that they want first? Huh. Hold on. I remember seeing this question before and I was like, is this a legitimate question? So EC2 and EBS I could see. CloudFront settings and S3 configurations, maybe. Elastic Cache without a database, that would be no. Redshift and EMR would be a no. This could be a yes. So, just to say this, because I think this is a really difficult question. I'm thinking it's either 2 or 4, actually. So it looks like most people are guessing 2, right? So let's take a shot and see if 2 is the answer, right? Oh my gosh, really? Huh. That is a shocker. Hold on. Oh man, it's a data analytics firm. Totally missed that at the very beginning, right? It says it right there. It's a data analytics firm. If it's data analytics firm, then the only options are going to be Redshift and EMR, unless we threw batch in there and some other things. Totally did not read the question, right? Because you can actually do parallelization and analytics with Redshift. That's what it's there for. And EMR with Hive and Spark and all that is totally what that's for. So, wow, didn't read the question at all, right? Yeah, data analytics. There we go. Okay, good on that section. So this was provision and automation. So let's switch over to security and compliance. Is this working for people? Again, we're just going to keep going, but it sounds like you guys are all hanging out. So it sounds like it's working. All right. Security. So companies developed a new website that's ready to be deployed in AWS and is to be made publicly available over the internet. I hope so, because it's a web server. But before they do so, the web server should support SSL TLS, since it's going to be delivering confidential information. So the website is required to meet regulatory and compliance requirements for the encryption of data in transit. Easy. Which of the following services will enable the company to provision certificates for sensitive data in transit for authentication purposes? This is a softball, right? Or a beach ball in some cases. This should be the answer. If it's not, then we probably missed a keyword in the question. Let's not repeat that. Our artifact, by the way, is a section in everybody's account that contains all of the attestations and certifications that AWS has. It is security related. I don't have to explain that. You already know. And roughly 3 is DNS, so that doesn't even make any sense. So even by process of elimination, if you didn't know what the certificate manager was, the other 3 definitely don't make sense. Okay. A well-funded cryptocurrency startup has a key management service on premise, which uses RCA asymmetric encryption algorithms and stores encryption keys. They are urgently planning to integrate their systems to a highly available secure service in AWS with FIPS 140-2 compliance. Stop. I don't even need to read the rest of the question at this point in time. Let me just tell you what happens. The minute you see FIPS 140-2 compliance, AWS has 2 services that do key cryptography. One is called KMS, right? And the other is called Cloud HSM. And I literally had to look because I forgot what the name of it was. It's Cloud HSM, which is a hardware version of the software version of KMS. So Cloud HSM literally is a dedicated hardware device that is dedicated to your account. It is the only one that is FIPS 140-2 compliant. You just have to know that right off the bat. It is the only reason to actually use Cloud HSM is because you want that 140-2 compliance. So if I look at the rest of this, now if I look at the answers, right? Keys must be stored in dedicated third-party validated hardware security modules under your exclusive control. Done. That cements it. Instantly, I know this is only Cloud HSM. I don't even need to read the rest of the question. Right? It's like, how can you implement this setup in a quick and efficient manner? Confirmed everything. I don't need to go through all the answers. I'm now just looking for Cloud HSM. So if there's only one, that's going to be it, right? Nothing else. So the minute you see that FIPS 140-2, the minute you see them say they want you to be on our hardware module, and there's no other qualifiers, because don't give you a false impression. I did read the rest of the question, right? Then you know it's going to be Cloud HSM. That should instantly lock into your brain. Okay. All right, number 3. SysOps admin needs to grant third-party vendor access to an AWS resource in the company's account to complete their integration project. After creating an AWS user account for the vendor, the administrator wants to restrict the access to specific AWS resources that they only need using an IAM policy and only for 2 weeks. Which of the following options would be an ideal policy to use? I don't know that I would have chosen any of those, but hold on. Okay, so first of all, bucket whatever comes off the table, right? Because if they want to use an IAM policy, we know automatically that they're not going to be using bucket anything, right? Bucket policy, bucket ACL, that's off the table, right? Under my assumption. Now, an inline policy or an AWS managed policy. Now, if you want to put conditions on a policy and you want to edit it, can you use an AWS managed policy? You can't edit an AWS managed policy. So you can't put conditions in there. And while inline is not recommended, it does allow you to customize it, right? So my thinking here, maybe this is off base, is that they actually are recommending an inline policy, because I don't think you can put conditions on a managed policy, but maybe I'm wrong. Let's check and see, right? But it's an inline policy, right? And let's go check and verify this. I don't think you can go in and modify a managed policy, so you couldn't put conditions on that anyway. There's no time boundaries inside a policy, outside of a policy. You actually have to put them inside the policy. For example, you could put a condition that says between this date range, right? We actually saw that in the examples. That only happens when you can actually edit the policy. Managed policies that are published by Amazon, you just have to take them as is. You can't edit them. Doesn't mean you can't copy the JSON out of them and make your own policies, but that's it. Now, obviously, bucket's not going to work for anything because that's all S3 specific. So that's off the table. Okay. I've been talking a lot, so I'm not going to talk for this one. So I'm going to let you follow your own process. So an online banking system is deployed AWS, which is going to be using an auto-scaling group of EC2 instances and an ALB, and there's an RDS instance behind these EC2 instances. To secure the personal data, you need to enable encryption for the database instance. Which of the following are incorrect statements regarding RDS encrypted database instance? So which of these two statements are incorrect about RDS? All right, take your best guesses. I know this one's tough. You really have to know a lot about RDS database encryption for this to function, right? Okay. So I see 2 1s and a 2. We'll just throw that out there, right? Let's see what happens. Haha. Good. Collectively, Adam, Isaac, and Nicholas all made the right answers, right? That's interesting. So the bottom line is that the following limitations exist. You can only enable encryption for an RDS database when you create it. You can't change it afterwards. You can't disable encryption once you've enabled it, right? That's not possible. You can't have like dissimilar read replicas. If the primary is encrypted, then the read replica has to be encrypted, right? Can't do that, right? You can't restore an unencrypted backup to an encrypted database instance. So that's not going to work. And then to copy an encrypted snapshot, you do actually have to specify the KMS key identifier, because it's going to have to decrypt it and then re-encrypt it over in the other region. But it needs to decrypt it, so you need to specify the KMS key and identifier in order to do it. So this is incorrect then. You can restore an unencrypted backup to an encrypted database instance. That's incorrect. You can have encrypted read replicas with an unencrypted primary. That's incorrect too, right? The rest of this is actually all true. Once they're encrypted, you can't be modified to disable encryption. You have to specify a KMS key in order to copy an RDS encrypted snapshot to another region. And then you can only enable encryption when you create it, not after the database. That's also all true, right? So again, this is deep level meta. This is why we have the practice exams. Obviously, this wasn't covered at a deep level in class. So you just have to come in here and memorize this. Okay. All right, so that was question number 4. So now we're going to pivot over to networking. Okay. Okay, so here I started deployed several EC2 instances into a VPC to host a web application. After creating the instances, the sysop administrator tries to establish an SSH connection to one of them. However, seems like we're unable to connect. What are the possible troubleshooting options for this problem? There's two here. So I'm gonna let you take a look at these and eliminate them on your own. I want to say this one seems like it's difficult, but if you know how, because this is a web application, so you can basically make some assumptions. If you know how the networking components string together, it makes sense. Remember, you're going from outside in. So you're going from outside the AWS network into an instance. Because there's really only two possibilities. There's something wrong with the network, there's something missing, or there's something wrong with the instance. That's it. Those are the only two possibilities. Okay. I got 3 votes for 3 thus far. Oh, I got a second vote for 4. Let's go for it. Okay. Let's check it out. Yeah, that's it. So first of all, just to make sure this is clear, NATs do not take inbound traffic. So it's the same as your home router. Your home router isn't going to take inbound traffic. Someone tries to get through your firewall on what is basically your firewall and your NAT gateway. It's not going to allow them to get in. So NATs do not allow inbound traffic, right? Now, don't get me wrong. You could punch a hole in your firewall, your home router, and allow inbound traffic. But typically NATs are outbound only. So you're not going to run through the NAT for SSH because that's not going to work because NATs don't do that. Verify that you're using a private network to access your EC2 instances. Well, you can't really do that because you're SSHing to it, right? So if it's on a private network, you're going to be going to a VPN. You're not going to be going across the internet, right? Number 5, verify the EC2 instance is registered in the application discovery service. No, the application discovery service is actually used for migration. So nothing gets automatically registered with a discovery service. That's actually a one-off service that's used for discovering applications and typically migrating them, right? Now, the internet gateway, if the internet gateway is not there, then nobody's going to be able to get into the instance. Matter of fact, that instance isn't even going to be able to get to the internet at all. So you probably have bigger problems than SSH. And verifying that the instance actually has hardware and the operating system is running, which is what the system status and instance status checks are, totally valid. If it's not up, because it's failed in some form or fashion, you're also not going to SSH into it. So that's why 3 and 4 here are the right answers. Okay. Question number 2. Financial startup has recently adopted a hybrid cloud infrastructure with AWS Cloud. They are planning to migrate their online payment system that supports an IPv6 address, and it uses Oracle in a rack configuration. Holy cow, rack, like a rack cluster? Woo. As a consultant, you have to make sure that the application can initiate outgoing traffic to the internet, but blocks any incoming traffic, right? Okay, financial startup, hybrid cloud. They're going to migrate their system that supports an IPv6 address, and they want outbound but not inbound. Okay, cool. All right. So what would you do to migrate the application to AWS? So first of all, does anyone know whether RDS supports Oracle rack clustering? That's the first question. Why? Because 3 and 4 have RDS in the answer. Does anyone know whether or not RDS supports Oracle rack clustering? Well, I'm going to tell you right now, RDS does not support any clustering other than the clustering it provides. So no MSQL clustering, no Sloaney, none of the custom open source stuff for Postgres or MySQL. Bottom line is that if you want to do clustering, you can't. You have to run it on EC2. So first of all, that answers a core question for us because we can't run rack and RDS. So done, no RDS. So now all you have to do is pick out of the remaining 2 answers, which the only difference it looks like is the difference between a NAT instance and an egress only internet gateway. Now, I see that Isaac said 2, Thomas said 2. Can either of you tell me why you think 2 is the answer? What is the key phrase in the question that makes you think that 2 is the answer for this? Well, just to say this though, is that a NAT instance will also block inbound, right? Because it only goes outbound as well. So then what's the distinction between a NAT instance and an egress only gateway if they both only allow outbound access? Because that's what egress only is, right? So what's the distinction that makes you determine whether 2 is the answer versus 1? Again, they both block incoming traffic, both require route table management, right? So here's the distinction, because you're not wrong, right? But I just want to make sure that your logic is solid. It says support IPv6. Guess what? A NAT gateway, sorry, a NAT instance doesn't support IPv6 by default, whereas an egress internet only gateway does, actually. That's the distinction that makes that the right answer, is that because it says IPv6, that's why that's the right answer. And if you go look at it down here, it says IPv6, and it'll tell you that you have to use an egress only gateway to do that. So, by the way, I don't know that that's no longer true. I remember a couple months ago they changed that, but on the exam it's still true. So you should just honor that, right? But that's why, because remember, RDS first of all won't support rack, so that's not even on the table. But NAT instances, right, but will not support IPv6 addresses. But I don't even know why they said that, because you can't run rack on RDS. Okay. So the reason we came to this answer is because of Oracle rack, which by the way, will not run on RDS. The other reason we came to this instance is because it says it wants an IPv6 address, which is only an egress only gateway as of this question, of this exam. Cool. Good. I just want you to have the key distinctions that tell you exactly what the answer is. Okay. We've got an energy company who's trying to establish a static VPN connection between an on-premise and a VPC. You created the required virtual private gateway, which is in AWS. You have the customer gateway, and you've got the VPN connection, including the router configuration on the customer side. So although the VPN connection status seems okay in the console, it's not quite working when you connect to an EC2 instance in their VPC from one of your on-premise machines. What does that mean? It's not entirely working. What does that mean? Is it not working? Is it like failing or losing connection? That's a weird statement. Let's just assume it's failing. Okay. How can you resolve this issue? Because it's kind of working, right? So the connection is not working. So do you add a customer gateway route with the destination of your on-premise network? Do you add an internet gateway for IPv4 traffic and IPv6 traffic? Do you create a VPC endpoint? Do you add a virtual private gateway route with the destination of your on-premise network in the route table? Okay. So first of all, we don't need to mess with an internet gateway. So I'm going to take, number 2 off the plate for you, right? You might create a VPC endpoint, but again, that's actually to get to public services. So I think 2 and 3 are off the table. So what we have left is 1 and 4, which makes sense. So I got a guess of 1 thus far. Anybody else? Or I'm sorry, Thomas, it might not be a guess. You might be like, no, I know it's 1. All right, let's go for it. So actually the answer is that you're going to modify the virtual private gateway route, right? And remember, most of these answers center on AWS services, not on the customer side. So you would actually go into the virtual private gateway, and then you would actually add a route for your on-premise network, right? Now, I got to tell you, this question is a little vague because we don't know how it's failing. Is it not initiating at all? Or is it initiating and then we're not getting any return traffic? Like, honestly, I'd probably look at the VPC flow logs and see if I can figure out what was going on. That being said, the only thing you can modify really is the virtual private gateway. You're not going to modify the customer. There is no customer gateway route on the AWS side. There's only the virtual private gateway route on the AWS side. So that's not necessarily wrong, but since most of this focuses on AWS services, it's going to be a VGW, right? And by the way, that is the only place that you would put the route for your on-premise network, because your customer gateway should already know where your on-premise network is. So the first answer doesn't actually make a lot of sense because it should already know what's behind it, right? Good, okay. Okay, so one of the big four accounting firms has recently hired you as their new IT consultant. You need to build a hybrid cloud architecture. So you've got some in AWS and some on premise, and you've got to satisfy regulatory requirements using private connectivity between your on-premise network to AWS. Which of the following services would you do that for? This is something that I mentioned out of band when we did the review this morning, right? And I am heartened to see that you know the shorthand and you all know the answer, right? Which is Direct Connect. That's the one where I was confusing the megabytes and the gigabytes because coffee. So, right. So this is like how this works. Remember, this is 110 or 100 gigabit connections. So, all right, good. Let's go through cost and performance. Let's do these last four and we'll check in. Hello. Hello. Okay. So an admin has been instructed to migrate an application from on-premise to AWS. Architecture should be highly available and secure against common web exploits, such as SQL injection and cross-site scripting and brute force attacks. Which two things should they do to prevent cross-site scripting, SQL injection, and HTTP flood attacks? What would they need to do? Let's pick two.
And Michael, you're muted, by the way.
Oh, good. I'm glad I said all that. Thank you. So first and foremost is that the WAF makes total sense because that's going to stop your cross-site scripting and your SQL injection. Now, Shield Advanced is probably a little bit of overkill because while that would actually kind of mitigate the attack, Amazon's already going to defend a load balancer from any kind of brute force HTTP flood attacks. Because remember, it's a virtual device. So Amazon's going to take care of that for you. You won't even see it actually in most cases. So you can actually just put an ALB in front of the system and allow it to defend against those HTTP attacks. The reason you wouldn't put a network load balancer is network load balancers don't handle HTTP traffic. Don't get me wrong, you can put port 80 in there if you just want to do pure network ports. But when we're talking about layer 7 HTTP traffic, an ALB is your friend, right? And the firewall manager, by the way, distributes rules to WAFs. So that's not even a product that you would put in there, right? So 1 and 2 would be the right answers here in this particular case, the lowest, easiest answers. Remember, you don't need Shield Advanced unless you need more distributed denial of service protection and you need cost mitigation. If it says you want cost mitigation, that's when Shield Advanced should be an answer. Just to draw that distinction. Okay, Google, set hallway to 70. So question number 2, a known security vulnerability was discovered in an outdated operating system of your EC2 instances. As the admin, you're responsible for patching those vulnerabilities as soon as possible. What is the most efficient way to solve this issue if you want to solve it for the entire fleet of instances? This one's a little bit of a gimme. There's really only one answer here. Yeah, I see people looking on 3. Systems manager is the answer. You can't actually configure EC2 fleets to automatically patch themselves. That's what system manager is for, right? That's what it does. Okay. Let's see. A digital advertising company has a set of S3 buckets that contain various data such as ad click-through rate, cost per click, CPC, and many others. The analytics management team needs to analyze the data hosted in the S3 bucket using standard SQL to reduce reports. Which of the following services could help meet their demands? Now, I got to tell you, if you know anything about analytics in AWS, there's possibly 2 answers, but they left a word out that makes one of them invalid. One of them I showed you already about running standard S3 against structured S3 data. So running SQL, sorry, against structured S3 data. So hopefully it makes sense which one it most likely is. So I got to tell you, I would probably guess it was Athena because that's what Athena is designed for. Just so you're aware, if it said Redshift Spectrum, Spectrum is designed to pull in data from S3, but because it just said Redshift, I was like, no, it's probably going to be Athena, right? Athena was designed to read structured S3 data, and you could run SQL queries against them. It uses Presto, has its distributed SQL engine. So, you know, in this case, since they didn't say Spectrum, we're just going to let that go. It's probably Athena. That's Trixie. If it said Redshift Spectrum, it would work. So, all right, last one for billing. A government agency needs to automate recurring tasks in their finance department, such as data synchronization, infrastructure selection, and patch management, which will improve their current processes. The SysOps admin needs to know of a tool which can coordinate multiple AWS services into serverless workflows. That's the key right there. Which of these is the most cost-effective service for coordinating into serverless workflows? I see multiple votes for Lambda, right? But here's the interesting thing. The answer is actually step functions. So serverless is Lambda, serverless workflows is step functions. So step functions job is to actually coordinate Lambdas together, bunch of Lambdas, right? It actually can do an external application, but mainly it's Lambdas, right? So step functions job is to create workflows. So instantly when you see serverless workflows, we're talking about step functions. If it was just like, hey, I want a bunch of serverless runs or applications, then it would be Lambda, right? Just to clarify that. Okay. So that's actually the 4th question inside all the sections. We can keep going. Does anyone, like, just to check, do we want to stop? Do we want to keep going? Because we can be done, or we can like do the next 27 minutes. I'm totally open to either one. Sounds like we've got some momentum, so we could keep going. Okay. Let's do it. Just do another like round, if you will, right? But just know if you want to drop off, it's been a pleasure to have you here. Please drop off, go take care of yourself, do whatever. But I'm going to run through another round of questions until 5, right? So, all right. So again, know that I won't be offended. It's been great to have you. But if you need to go, you can just drop. Thank you for a great class. Thank you for participating. It's been an awesome 3 days. I will send you an email that will have all my information in it, so you can contact me or Greg or anybody. So again, if you want to go, please feel free to drop off. And it was great to have you. So if you need anything, just let me know. Okay. All right. Let's go back to monitoring logging. Actually, you know what? Let's switch to a review mode exam. Let's mix it up a little bit. Wait, hold on one second. Okay. All right, so let's start this next quiz. Let's run through these again. Or sorry, different set. Okay. By the way, if I see a question that's a repeat, I'll skip it. Huh. That's pretty close, actually. But hold on. All right. So, but it's not the same. Lead system engineer creating a CloudFormation stack that needs to be deployed into VPC. There is one particular CloudFormation stack that's going to use a template to create a VPC, an EC2 instances, and an RDS instance, and an internet gateway. What should the engineer use to make sure there's no errors when deploying that stack, right? What should the engineer choose for that? Creation policy, that might make sense, right? Anybody else? Okay. Just to say this is that since there is actual hierarchy for how things should be created, you want to use the depends on attribute. Why? Because you need the VPC before you can create the internet gateway and put it out there. The internet gateway requires the VPC. Then you want to create the database after you've created the internet gateway and the VPC. And then you want to create the web servers before you create the RDS database. So this is not an external thing where you're configuring an operating system per se. This is just about like order of dependence, right? So you actually want to use the depends on attribute first to actually make sure that you're putting them in the right order. Yeah, so there's no external per se. So no one said that in the question. So you don't need to worry about CNFN signal. Kudos for answering though. Okay. Company's got a Node.js application running an on-demand EC2 instance, which requires temporary credentials for authentication and authorization, et cetera. To properly set up, you need to pass a role to EC2 to use with the instance. Which of the following IAM actions should you define in your policy to allow a user to pass a role to an AWS service? We talked about this, right? So hopefully this makes sense. So I see 3, a couple of people answered 3. Let's see. That's right. Pass role is it. You have to have the ability to pass a role to a service to assign that service a role. Okay. A sysops admin notices a spike in request count metric for an ALB that triggers a scale up event for an auto scaling group. Admin needs to identify the source IP address of the requests that scaled up the ASG. What do you need to get access to in order to see the client side information from the load balancer? That probably teed that up a little too much. Okay, good. So I've seen 1 and 4 thus far. Any other guesses or answers? Okay. I'm going to hedge bets here. I know it's not CloudTrail because CloudTrail is for API calls, not for network traffic. So I'm going to do the load balancer access logs, right? Now, first of all, auto scaling group logs, I don't think those exist. EC2 instance logs, those don't really exist unless you're pushing logs into CloudWatch logs. CloudWatch trail logs are only for API calls, not for network traffic. Network traffic can only be seen either through the VPC flow logs, but if you want to see network traffic, like client traffic that's hitting a load balancer, You got to look at the ELB access logs, which has to be enabled, by the way, right? So since this particular case, she's looking for the source IP addresses of the requests that came in through the load balancer. That's going to be the access logs to grant those, right? Okay. Remember, if it's a non-AWS user, meaning that user is not logging in through IAM, it's not going to show up in CloudTrail. CloudTrail only captures API calls made by IAM users. Let's see, Isaac, how do they verify which one sets off the growth? Well, what you do is you see when in CloudWatch, you would see when the auto scaling event got triggered, and then you would go look at the client logs and see which ones happened just ahead of time. Because what you would see is you would just see a surge in the number of requests, and that would cause the auto scaling group. Yeah, you just match timelines. That's all it is. It's just time correlation. By the way, those ELB logs could be ingested in CloudWatch logs, so you could actually correlate all the logs together. Okay. A media company is heavily using various AWS services for their daily operations. Your manager wants to get utilization and be able to know which areas of their cloud architectures they can optimize to save on costs. This one's a little bit of a softball. Which of these would give you detailed information on utilization? Isaac, that's good. Yeah, so 4, right? Kerr is the only one, right, that would provide that information. Good. Okay. Big question. Got a digital advertising company. Oh, we already answered this one. Yeah. Have a good one, Wesley. Thank you. We already actually answered this one, right? So I'm going to skip this question. All right. So SysOps administrator has a fleet of EC2 instances inside an auto-scaling group and a couple of Lambda functions that are running inside the cloud infrastructure that she manages. Whenever she releases a weekly update of her code, inconsistencies occur due to not being able to manually update all relevant resources properly. Because of the large amount of resources present, she needs a way to group them together and deploy new versions of code consistently among groups with minimal downtime. So what could she use to deploy new versions of code among a bunch of disparate systems, right? Among different groups. Now, we didn't really talk about any of these services, the code services, right? Because they weren't in scope for our conversation. Yeah. If I were to guess, first of all, it's the only answer that talks about deployment groups, which is exactly what she's asking for. Code deploy does actually do automated code deployment. Let's take a gamble, see what happens. That's it. Yeah, the rest of this, some of it kind of makes sense, but not really. Okay. Okay, we already answered this one actually, so I'm going to skip it. Okay, startup company hosting their innovative AI-based application on EC2 instances is going to be used by thousands of users across the globe. You need to design their architecture to speed up the distribution of dynamic and static content to all of their global users. Which of the following services can you implement for this requirement? Yeah. Which one actually does caching of both static and dynamic content, but mainly static content? There's only one service. SQS doesn't do it. That's a queue. That's a bus. SNS is a notification service, and Lambda is serverless. So even by elimination, CloudFront would probably be the only possible answer. And so if we check it, the answer is CloudFront. Okay. Companies hosting a video streaming website in CloudFront. There are times that the website receives malicious attacks such as SQL injection and denial of service attacks from unknown origins. Customers are affected because they've had a hard time accessing websites during these outages. So now we've got an SQL injection attacks and we've got distributed denial of service attacks. Which of the following services would you use to mitigate these attacks? The minute you see distributed denial of service, you automatically know one of the answers, right? And if it's any kind of cross-site scripting or SQL injection, you know the other answer, right? It's going to be Shield and WAF. Good. Okay, let's talking on this one. Research team recently used Elasticsearch with 4 data nodes. Oh man, this is like deep into Elasticsearch. For those of you who don't deal with Elasticsearch, I don't know why they would ask this question. Anyway, 4 data nodes experiencing downtime issues. The sysops administrator needs to resolve the issue and ensure high availability in the infrastructure. What should they do to meet the infrastructure requirements? 4 data nodes. That doesn't make any sense. Hold on. Huh. This is more about Elasticsearch than it is about AWS, although it does talk about how distributed databases should be distributed. Okay, so I saw an answer for 2. I actually think that the answer is actually going to be 3, but so I would have been wrong actually. So there we go. So 3 master nodes to different availability zones. That's a key. Just so you know, the way Elasticsearch works, it works off a quorum, so 51%. So if you lose an availability zone, you still want the other 2 nodes. This avoids split brain. So for example, if you lose connectivity on one of the nodes, that node knows it no longer has a quorum, so it does not act as authoritative for its database. The other 2 nodes, since that would represent 66% of the total, they would know that they are authoritative because they're still talking to each other. 4 storage nodes in multiple availability zones. You could get away with 3 storage nodes. I don't know why it was 4, but regardless, it sounds like they wanted to stick with 4, but that wasn't clear from the question. Doesn't matter, right? That's the answer that they wanted. I gotta tell you, this question is more about Elasticsearch than it is about AWS, so that kind of throws me off a little bit. You wouldn't probably put the data nodes in different availability zones from the masters, because just to say this, 2 is not enough to establish a quorum. You need 3, 4, or more. Usually with Elasticsearch, at a minimum, you run 3. But again, this is an Elasticsearch question. This is not really an AWS question, right? But it is about Amazon Elasticsearch, so maybe that's what they're testing. All right, we're going to skip that. We're now back on the discussion of permission boundaries. Okay. Company is building a face recognition system using AWS deep learning AMIs to train sophisticated custom AI models and experiment with new algorithms. You tried to launch an on-demand instance to use a TensorFlow framework, but you are getting an instance limit exceeded error message every time you do it. What's the reason for the error and how do you solve it? All right, let's see. I see AWS does not have currently enough on-demand capacity, but it does say instant limits exceeded, right? Thinking 1 or 2. Okay. So are limits for EC2 instances regional or are they availability zone? Right? Which one is it? Let's take a guess and say it's regional. Right? So when we were in service quota before, there was a limit of like 1,920 boxes. That was a regional limit. It wasn't an AZ limit. And if it was an on-demand capacity problem, it would say no capacity available for instance or some variation thereof, right? But here it's saying basically that your quota limit has been exceeded when you try to start an instance. Look at this. Someone must have arbitrarily changed their instance limit to 0 so they would actually see this instance limit message pop up. That cracks me up. Good job, John. So, oh, here it is. Insufficient instance capacity. That's what you would see if you were trying to launch an on-demand instance and there was no capacity available. I haven't seen that in years, mainly in US East 1, but you probably won't see that normally. Okay. Organization setting up a WordPress website on 2 on-demand EC2 instances that are deployed on a public subnet. For its database tier, they are using MySQL in RDS, which is on a private subnet. During the initial testing, the sysops admin noticed the web services could not talk to the RDS instance. What do we need to check, right? What do we do to fix this? So the thing you need to know is, by default, can subnets talk to each other, right? That's the first thing. And then beyond that, what are the other factors that could potentially prohibit web service, systems talking together? What's the most likely culprit? Because I told you at the beginning, there's one thing that typically hangs everybody up about AWS, and it applies to not only IAM, but it also applies to networking as well, right? See a bunch of people put 1 in there. Yeah, typically it's security. By default, every subnet can talk to every other subnet. So there's no particular, and within the same VPC, there's no particular issue there. Typically, it's going to be a security problem, right? Okay. Data analytics company decides to augment their on-premise infrastructure with AWS. They need a new service that can analyze clickstream data from their global clients in order to segment users, understand preferences, and deal with ads. As the sysops administrator, you have to set up their cloud architecture where it can automatically provision thousands of compute instances to process data at any scale. Which should you do to meet the requirement? Now remember, this is analytics. This is not data storage. This is not data hosting. This is analytics. Which of these services relates to analytics? Okay. So DynamoDB actually is a data store. If you want to do analytics, MapReduce is going to be your friend. This is where Hive and Spark and this is where those services live. So when you want to analyze data and run like huge batch jobs to get reporting and predictions and algorithms and stuff like that, because this is a data analytics company, once again, MapReduce is your friend, right? If you say data analytics in the title of this question, it's probably going to be something around Kinesis, Elastic MapReduce, Batch, or Redshift. That's probably going to be the answer, right? So, well, what it does, Isaac, is that it actually like crunches the data set. It like reduces the data set down to something meaningful, right? But behind the scenes, it'll automatically grow the number of instances that are needed for the data set. But you're not wrong, right? Yeah. Elasticache is used for caching, relational database service, and DynamoDB are just data stores. Don't get me wrong. DynamoDB can handle a ridiculous amount of scale, but it's not really an analytics platform, right? It's more like transactional. Okay. All right, we have a bank that is implementing a hybrid cloud architecture, and there's a requirement to use S3 as your primary data storage while retaining frequently accessed data locally in your storage gateway. The objective is to minimize the need to scale your on-premise storage infrastructure while still providing your applications with low latency access to frequently accessed data. Which type of AWS storage gateway is best to use for this scenario, right? That's the question. So I gotta say this is that we didn't touch on storage gateway at all. It wasn't even talked about, but it is a pretty old and core service that AWS has had around for like 10 years. So, I'm just going to analyze this one because most people may not be familiar with this service, right? So they want to use S3 as your primary data storage while retaining frequently accessed data locally in your storage gateway. So a file gateway could be an answer, right? Let's check it out. I don't think it's a volume set, but it could be. Yeah, it could be a volume set. So what they're doing here, so by using cache volumes, you basically can keep S3 as your primary storage while retaining frequently accessed data in your cache on your storage gateway, right? And so you can attach volumes up to 32 terabytes in size from a local like SAN system to your storage gateway, and it will represent them as volumes that people can mount. Now, that data is then snapshotted and cached inside of S3, but they're snapshots. So it was a little confusing because it made it seem like they wanted you to have direct access to S3 objects, but you don't. You have access to S3 snapshots, which is a little different, right? Because then you can take those snapshots and restore them to disks, like EBS disks, and then attach them to EC2 instances. So this question's a little off. Okay, let's do one more. By the way, the storage gateway can act as a virtual tape library. It can act as a file gateway, and it can act as a volume gateway. And the volume gateway, as we saw in the answers, there's two different types. There's one where it caches, and there's another where it does a complete copy and replication between both sites. So the storage gateway is a topic that you're going to probably see in that sheet that I'm sending you that you're going to need to look at. Okay. Last question. Oh, yeah. Cloud engineer is assigned to write 2 CloudFormation templates in YAML format. The first contains the configuration about networking, including the route tables, the internet gateway, the VPCs, all that stuff. The second is written to deploy the infrastructure and applications that were created in the first template, right? So what is the best way that takes the least amount of administrative effort after the stacks are deployed? What's the best way to accomplish this task? We didn't overemphasize this, but we did say in best practices that you could do what they're suggesting here, the answer. So just to say this, Thomas, I agree with this, is that I do this a lot actually, where I say, what's the name of the other stack? So I can refer to that stack and gather information out of it. But I have a feeling that they're actually asking for something else. The reason this is thrown off is because of that use of the word resources, right? What they should probably say is like, what are the outputs? Because when a stack publishes outputs, other stacks can actually grab that information, right? So on the first template, what you're going to do is you're going to create outputs and then export the fields out. And then that allows you to import the functions into the second field, referring to the first stack's values. So how this works is that you start the first stack, and when it starts, it outputs those fields. Then literally you could say in the parameter section of the second stack, you could say, hey, what's the name of the first stack? And what it will do is then it will go look for the output values and grab the values that you have imported into the second stack. So you can literally chain stacks together. So they are referring to previous options, previous like variables that are in a previous stack. So if you're running the EC2 stack and you need networking information, you can grab it from the networking stack. If you're in the application stack and you need the EC2 instances, you can literally grab from the application stack, you can grab the EC2 information, right? You can literally go get it, but only if it's exported. It has to be in outputs really for it to show up. Okay. All right. Technically, we're done. It's 4:59. Thank you so much for your time. I hope that was useful. All of this is being recorded, so you get to re-review it again if you miss an answer, right? Isaac, yes. To answer your question, if you want to see the exported output, you can actually grab it on the command line. But if you are also inside, you can actually go to CloudFormation. And if you pick a stack, let's say I do the one I did before. If you click on outputs, you can actually see everything it's exporting. Right, you can also grab that off the command line as well. Good. Glad to hear that this was useful. Keep going forward. I'll send you an email in about 24 to 48 hours. It might be Friday. It's probably going to be tomorrow. The videos will be processed and all that during that time. So have an excellent week. Thank you for spending 3 days with me on system operations. Any questions, write me. Otherwise, go forth, pass the exam. Hopefully we'll talk again soon, and I'll see you in the next class, okay? Thanks, everyone.